ठीक है। ये फर्स्ट VM का IP है, यूजर है pyadmin. I might change the username. Let me do it right away before giving it to you. Or you can try it now, no problem. Pyadmin, and password is इसको RDP करके एक बार चेक करना. सौरभ, आ रहा है RDP? हेलो.
हाँ, अरे सॉरी मेरा म्यूट था, पता ही नहीं, मैं तुमसे तब से बुला रहा था. तो ये RDP करना है कि ये ब्राउजर में टेस्ट करना है?
नहीं, RDP, डायरेक्ट RDP करना. वो 1 मिनट.
ये RDP अलाउ करेगा, क्योंकि ये तो RDP में ये अलाउ करेगा. इसका क्रेडेंशियल्स क्या है?
ये दिया है मैंने, pyadmin करके यूजर है और पासवर्ड है pytraining@1234.
मतलब कोई डोमेन वगैरह कुछ नहीं है? ये डोमेन
नहीं,
मुझे
नहीं, कोई जरूरत नहीं. डोमेन इज IP एड्रेस ओनली, सो नॉट रिक्वायर्ड.
बट यहाँ पे तो डोमेन ठीक है, देखता हूँ मैं. एडमिन पाई ट्रेनिंग. हाँ,
आ गया रिमोट.
ले रहा है, अब देखते हैं.
स्क्रीन शेयर कर देना आपकी, तो मैं आपको बता देता हूँ.
मैं स्क्रीन शेयर कर रहा हूँ ना?
हाँ.
ओके. दिख रहा है ना मेरा स्क्रीन?
हाँ जी, तो
यही
ये
है.
क्लोज कर देना. और अगर आप C ड्राइव में जाओगे अभी, तो यहाँ पे सेटअप्स करके एक फोल्डर है.
Hello.
ओके. हाँ, हेलो तापस.
Hello. Yeah, Animesh. Atul sir, sorry sir. Actually, I was traveling. That's why I got late. I'm really sorry.
No problem. So Tapas, what we are doing, we are just testing the VMs. Okay.
Okay.
As you are here, I will also start your VM. Okay. So, Saurav, as you can see, so I have copied SQL Server Express here. So we will start from the SQL installation itself. Okay. And then we have PyServer 2018. We are not doing 2023 right now because most of the time we only do n-1. Okay. If you want, we can you can download your latest license for 2023 and we can work on that. Means if you have the access, otherwise
No, I don't have. We don't have. As I
it
said,
is
we don't have the
almost the same.
SRP,
It
right?
is almost the same. You will not have any deep, like major 99% it will be same, only small here and there because as it is a software, right? It always get updated. So there is no change in the installation, only a few things added here and there. That's it. So we will be installing PyServer 2018 SP3 patch 3. Then we will be doing like once the PyServer is installed, inside the PyServer installation itself, there will be a total 4 components like PyData Archive, PyAsset Framework, PyAssetAnalysis, and event frames and notifications. Okay. So these 4 components will be installed in one setup, and then we will be using this Pi license, which is downloaded for these systems only, and this license will be accessible till 20th of December. Okay, so the validity of license is for 20th of December only. But like after the installation, these systems are only for the installation purpose. Okay, then we will be working on a separate server that I will be installing for you with the data of 1 month, and then we will be working on that server. Okay. Yeah, so this is only for your practice, this server only for your installation practice. Okay. Yeah. So
Animesh, all these installations you will do right now one by one or what?
Sorry?
So all these installations you are saying you will do right now?
Installation part we will start tomorrow.
Okay.
So today we will be doing
gentlemen, 1 minute. Can I step in?
Yes, sir. Yes, sir.
So good. Now that everybody is here, so let's formally start this training. So isme the main things are that schedule is already in the hands of everybody, right? Saurav and Tapash, you know day by day what is to be covered.
Yes.
So now Animesh, try to stick to that. By and large, there'll be little here and there and some requests from Saurav and Tapash to repeat something or to move this from this date to that date. So that is fine. So as long as both of the flexibility
so
you can exercise. Okay. Is it better now?
Yes, sir.
Okay, so basically flexibility rahegi puri. I mean, you can decide what to do, what not to do. If you want to change the contents between days, give feedback to Animesh, and Animesh will definitely try to accommodate. Recording ho rahi hai. There'll be 2 sets of recordings, one through Teams, which Saurav is doing. In addition, Tapash and Animesh, you can try, and Tapash, you can understand from Animesh how to do it through Windows. So Tapash, you also do a recording so that there's a backup of the recording. And this file will be large. So see, Saurav will arrange for a mechanism to save it somewhere so that you can access it later when required. What I may suggest is you may choose to stop recording in areas where you think there's no value being transacted, which you may need to refer later, so that file sizes are a little manageable. But it is totally up to you.
Yes, sir.
Now, regarding the contents and timelines, we are clear. 7:30 every day in the morning, as per the dates mentioned in the document. So let's try to keep it that way. If there is some change required, someday you want to skip, which was not planned earlier, so that also is okay, as long as Animesh is okay. So mutually you can agree on changes to the schedule as well. And yes, content-wise, it's totally flexible. Other than what is mentioned in the document content, you can ask any questions related to why. And we are not very straight-jacketed कि बस इसी scope के अंदर करना है. But understand the limitations of time. That is important.
Yeah.
Okay. So
sir.
with that, any questions at high level?
Sir, I just
Saurabh,
wanted to
Tapas?
like mention one thing. Like I'm at site right now, so there will be a possibility that sometimes maybe for 5, like sometimes if something comes up, then I may have to we may have to stop for 5-10 minutes, and we'll have to consider it as a break only, because I'll have to handle the other request as well. Like it won't come, or most probably, but if something urgent comes up, then I'll have to take that call or handle some request. So that is one thing.
No.
Hello.
Okay. Yeah.
Answer
Good.
That's
okay.
Answer second is there has to be a little bit flexibility on the dates, because there, like as Tapash is out on won't be available on 8 and 10. So and for I think I'll be flying out on 13th December. So that day, if my flight is delayed, then it's fine. We can continue that class for that day. But the day I'll be coming into site, that day we might have to postpone the class. It's something we'll have to be a little bit flexible. Not every day, but like sometimes maybe in a week or two, we'll have to consider that.
Yeah, that's not an issue. Just keep Animesh's convenience also in mind. So
Yeah,
between you and Animesh, you do whatever you want. Yes, flexibility is not an issue.
Okay, sir.
Yeah, Tapas, basically the training content that we have chalked down, it is not that lengthy or that big. So daily 2 to 3 hours is more than enough for it. Depending on, because it is an interactive section, because you will be asking question, and because there might be some issue that you will be facing while doing the practice or just doing it yourself. So that is the reason we have kept it for the 4 hours. If that is the case, and if you think that some days might be like we need to skip, what we can do, if we spare the time in first day, so we can just incorporate next day's few points in that day itself, so that way we can just take care of the missing days and all. So we don't need to stretch it more. So if you need time to do the practice, if you are okay doing it next day, I'm okay. If you want to combine it in same day itself, few points we can just take like next day's point in that day itself.
Okay.
Animesh, what I'll suggest is let's start this, and then we'll while because it's we all are unaware right now, what is ahead of us, right? So depending upon how how much we can take in a day, so we might decide we can decide going forward that how how should how the delivery should be, or how our schedule should be,
So
because
no
right
problem.
now we are not able to tell anything.
Yeah, it's totally on you people, right? So if you
Yeah.
if you get it quickly, and if you are okay doing the practice, you are not facing any issue during the practice, then it's okay. Like you yourself will see it, and if not, then we are okay. So anyway, we have allocated 3 to 4 hours every day, so that's not a problem.
Okay.
Yeah.
So
Okay,
yes,
we can start.
Saurabh, you're right. I mean, it's ultimately you and Tapash who have to say, yes, we are good with this content. Now we can go to the next. What Animesh is saying is, if you feel that there's a lot of time available on day 3, for example, then you could cover some topics of day.
Yeah. That's fine. Yes, sir. No problem.
Yeah. And likewise, day on 13th, you can skip it. You can take it on 12th or on 14th, part of it, whatever. So,
Yeah, that's fine.
you see,
yeah.
as per your satisfaction and as per Animesh's convenience, you can do whatever you want.
Okay, sir.
Now, regarding training materials, it's clear the links from OSI Viva will be given to you, and recording is happening. Other than that, there's nothing else expected, right? Training material wise.
So as requested earlier, like if Animesh can give us a crisp training document, like other than those OSI documents, because those OSI documents are very detailed, like it's so few hundred pages documents. So if something he can make it crisp, but like specifically for some topics, like let's suppose some PyPoint, how to configure a PyPoint, or how to do AF your frameworks, or generating templates. So those basic things, or how to configure Pi interface. So those things are
With some
what all.
screenshots. With
Yeah, some screenshots.
You
If
see,
something like
that
what
is-
all things keep in mind.
Understood. So what you're saying is to kind of make a brief user manual. Now,
Yes, sir.
that is a very time-taking thing, and that I do not think would be possible. So training material, essentially, you'll have to bank on the Aviva's things. And if you want something more, cheat sheet kind of a thing, then what could be done is that jointly you can make. So sort of, Tapash, you can start making something where you think you may need some handy reference, and Animesh can help saying this, or you can ask questions, he can give you the right inputs, and you can record or put it in a Word file or whatever. But making a user manual would be difficult, even a small abridged one. Some small points he can put together, but then with screenshots and to make it the way I understand you're saying would not be possible.
Yeah, okay. So actually what there is a tool over there, like see why I was telling is because we are also new to this, so we might, so if we do that kind of a document, there will be a lot of issues like confusions and everything. So but he has done it a lot of times, Animesh. So if he can, because there is a tool in the Windows itself, like whenever you will click it, it will just record the screenshot. So you don't have to do it. So maybe at one instance, if you can do the entire steps, it will automatically generate the document. So it is there in Windows. We can discuss on that, but yeah, so it's up to him, like if he's like if he agrees, or even we can do that, but it might have a little bit of here and there. That's why, like because at last the intention is that we will learn how to configure all these things, right? So to keep it in our mind, so and everything holding up in our memory is difficult, so to go
absolutely.
through quick.
So whenever any trainee is attending a course, they take down their own notes, because
So
as
that
you
we are
rightly
taking.
said, everything cannot. Yeah, so take notes, and Animesh can help you. Take screenshots, as you said, and put it in your notes. Animesh can help you, and if something is to be repeated, he'll repeat that. But to expect a ready-made user manual, that would be, I'm saying, not possible. But yes, what you're saying, definitely, it's a normal training procedure where trainees would take their own notes. So do that. And Animesh
Yeah,
will
okay,
help.
sir. Yeah, okay, sir.
Okay. Okay, good. So I'll sign off now. Wish you all the best. I hope this is a very fruitful engagement. And the intent is that you come out at the other end reasonably knowledgeable, so that you can handle Pi questions, Pi issues, Pi maintenance on your own. And of course, you will not become an expert in these 14 days, but then you should be able to manage. And we'll continue to be available for help, little Q&As even after the training is done, if you face some difficulties. So wish you all the best. I'll sign off
Okay,
now.
sir. Thank you, sir.
Okay.
Thank
Okay,
you,
Animesh,
sir.
over to you.
Thank you.
Okay, bye. And Animesh, just give me day to day, just a little message. It was done, and highlight any face that day.
Sure, sir.
That's
Sure.
it.
Sir. Yes, sir.
Okay. Thank you. Have a fruitful discussions.
Yeah. Thank you, sir.
Thank you.
I may jump in on some days, so I'll have the invite with me. So this invite is for, you'll send an invite every day, is it?
No, sir, I have sent it for 3 days till 7th, and after 7th, I'll just send for the next whatever the days we'll decide. Based on that, I'll send.
Perfect. So keep sending me the invites also.
Sure, sir.
I'd like to jump in off and on.
Okay, sir. Sure, sir.
Okay. Okay then. Bye.
Okay. Okay, sir. Bye.
Thank you. Tapas, I shared the detail of second VM. Can you just try and see if you will be able to log in? So you just need to do the RDP.
Okay. And I have opened remote desktop connection. What IP I will put?
Yeah, in chat I have given you the IP 98.70.66.156.
98, yes. 98.70.66.156. User credentials. My admin. 1, 2, 3, 4.
Okay, you're getting connection?
No, your credentials did not work. It is showing tsmc/tapas.das.
No. You
And
need to
asking for
put the
password.
file. I mean, you just need to click on use different user and then put the credentials PyAdmin and the PyTraining at the rate 1234.
Okay, I have to make a different
Can you share
user.
screen?
Okay. Use a different user. 1 minute. PyAdmin and name at 1, 2, 3, 4. Yes. Now I'm able to open that system 98.70.66.156.
Okay. So once you go inside, you can just go into the C drive.
So I am in C drive.
There should be a folder called setups.
Setups, yes.
Yeah, and you will see the setup files there and the license file.
Yes. So you want me to share my screen or what?
No, it's fine for now. I just wanted
Okay.
to confirm that you are getting the remote, so we don't need the server today itself. So I will be shutting down it in a couple of hours, and tomorrow it will be available for you. I might change the username because it is same to the another inbuilt user. So I just don't want to make mess with the same name. So I will just change it slightly. I will just put PyAdmin VM1, PyAdmin VM2 like that. Okay. So I will just change it slightly. Anyway, so what we can do, we can start our today's session. Okay. You can stop me anytime and ask me your question, as it is an interactive session. So please ask your question as and when you have it. And then, yeah, we can just take a 2 to 5 minutes break after every hour or so, just to stretch your legs and all. So that's it. So, and let me know if you want to stop in between for like if you have any work. Okay.
Yeah. Okay.
Let me share my screen.
Okay, I'll have to stop sharing my screen.
Yeah.
Okay.
So you can see my screen, right?
Yeah.
Yes.
Yeah. So I think you have already done some like online searching about the Pi system, and you may have learned about few things about the Pi system online, right? Already.
No. Don't think
No,
think that
no,
we
Animesh, you
don't
have to start
anything.
I'm
from
I'm
zero.
I'm covering everything, so don't worry. So just starting with the Pi system and like what exactly is the Pi system. So initially, so Pi system is not a new tool. So though this Industry 4.0 and digitization is the new concept, like 5-10 years back, but Pi system is a quite old tool, like 40 plus years, and it has evolved over the time. Talking about the Pi system, so OSIsoft has started the Pi system as a data historian. So you know what data historian is, right? So like it is only to collect and store the data from all sort of assets, like basically the OPCs and DCS and PLCs, and few of the databases. So Pi started as a data historian, and then it evolved by the time as a data infrastructure, what we call it today. So as you can see, the Pi system can collect the data from almost all sort of uh, like you can say assets or all sort of data sources which has a kind of sensors in it, or like the data is available digitally to collect from those data sources. So data sources can be of multiple forms, right? So it can be your databases, or it can be your assets, or the file formats and all. So Pi system has started collecting the operational data initially, and then it now evolved into a data infrastructure with the collection of metadata also, and integrating your multiple data sources into a single system. So we called it as a single source of truth, and all of your uh, critical information uh, for running your mill or doing the analysis part. So all the information will be available at one place for you. So that is what we called as a Pi system and the data infrastructure. Okay. So as you can see, this is a kind of rough architecture of Pi system. So we will be looking for the detailed architecture. So starting with the data sources. So in this case, your data sources can be anything. In the case of TSMC, if talking specifically, so you are into the mining and the like metal and mining business, the processing, doing the mining, processing the raw material and all. So in this case, your asset can be your mining equipments, or your transporting equipments, and in the end the processing plant where you process the iron ore and all. So in this case, your asset can be the vehicle, can be the big machineries which drilled into the mine, or the machineries inside your plant, which can be the conveyor belt or crusher, or the CU machine, or any other, like if you have the captive power plant in this case, your power plant, the turbines, pumps, on all other equipments can be your data sources. So those are the assets we call, and then you will be collecting the real-time information, the time series data from those assets. So that will be your one part. So data might be coming from a sensor, which is an IoT sensors nowadays, which we put on the moving equipment like the trucks and the conveyor belts or the pumps which are remotely located, or there will be PLCs, there will be OPC servers, there will be DCS from where you will be collecting the data, the process data in particular. Then we will be having some data which is on premises, like which is the database which will be maintaining the metadata about those assets, or about the production planning, or about the maintenance. So any information that is required to combine with your process data, which is available inside a database or inside a file format like CSVs or text file. So those also can be our data sources. So these kind of data
Animesh,
sources.
what is this metadata?
Yeah.
Like, what do you mean by metadata?
Right. So giving an example, when you will be having, just consider one asset, okay, one asset or one area, or like anything, a section where you have a pump, right? So pump is your one asset, and you will be collecting the process data, which is the real-time information coming from the pump. In this case, there will be vibration, temperature, then electric current and other parameters from your pump. That will be your process data, right? But there will also be some information about that pump, right? So where that pump is located, the very first thing, the make and model of that pump, the capacity of that pump, right? So this kind of information, you can consider it as a metadata, right? Which will actually be used in a multiple ways, right? So in location, if you see, so suppose you are monitoring a pump, so there is a screen particularly made for a pump, right? And then a pump is showing you unhealthy, or it is showing you some uh, problems in the data. So what you can do, you can just go and check where that pump is located, right? So you really don't need to go and check in your other system like SAP and all, right? So what is the M number of that pump? So what is the make and model? If if you have make and model handy with you, you can just go and check the spares available for that make and model, right? So these kind of data and the capacity. So suppose you know the capacity of that pump, and every time you install any asset, they give you the detail of the capacity, and by the time, by the years, how it will be decreased. So using that information, you can use the same information in your calculation, and you can calculate the OEE, right? Overall equipment efficiency kind of thing. So these kind of data can be a metadata. Then another thing is the upper and lower limit, right? So your upper and lower limit is not coming from anywhere, right? Though your set points are there, right? Though you will be changing your set points, but though you change the set points, you need to mention your upper and lower limit. So suppose my set point is 50. So how much deviation is allowed for that particular parameter? So if my set point is 50 and only 1% deviation is allowed, so in that case, my upper and lower limit will be 0.5, right? So it will be 50.5 or 49.5, right? So that will be my upper and lower limit. So these kind of data we consider as metadata, and some more information like when the last time this like asset is meant, like what is the last maintenance time, what is the information at the last maintenance, or there is any finding. So this kind of information we call as metadata.
So Animesh, can we say that for an equipment in Pi, we collect process data and metadata?
Yes.
Okay.
So pi like I will show you, like it is just the next part. So now we have seen the data sources, right? And to
Right.
collect the data from the data sources, we have different kind of interfaces and connectors. So Pi has around 500 plus interfaces, connectors, and adapters available to collect data from different type of systems, right? You may have seen many databases, you may have seen many historian, right? But the major plus point of Pi system is the range of interfaces and the collectors they have, right? So they have huge number of interfaces and collectors, so you will be able to collect data from almost all type of digital equipment. Like if data is getting in digital format, almost all format you will be able to collect the data from. So going forward, so these are the component of a Pi system. So Pi system is not only the database, okay? So database is only the base of the like Pi system, you can say. So whatever process data you will be collecting, that data will be going into your Pi data archive. So Pi system don't have the SQL, like they don't use the SQL database or any other RDBMS database to store the data. Okay, so the data will be stored inside a file called archive file. Okay, so the extension will be .arc, and we call this archive file, and the data will be stored inside Pi data archive. So we call it Pi server. So the whenever we will be saying Pi server, we will be referring to the Pi data archive. Okay, most of the time. Then the second major component, which is giving meaning to the data, we call is a Pi asset framework. So this is the place where you will be storing your metadata. Okay, so the process data will be stored inside the Pi data archive, and your all other information, all the metadata will go inside Pi asset framework. So Pi data archive is not able to store the data in RDBMS format, right? So no one parameter is related to another parameter in any way inside the data archive. Okay, inside the data archive, because every parameter will be storing the time series data. There will be a timestamp and there will be a value, and that is the only thing they will be storing inside a Pi tag. Okay, so one Pi tag refer to one parameter, and each Pi tag will be storing the timestamp and the value for that particular timestamp. So that will go into the data archive, and all other metadata will go inside asset framework. So you got it, where the metadata is stored?
Yeah, Animesh, this metadata is stored is understood. Like as you said, this asset framework will store the metadata. Sorry. So this asset framework can also store, like can also access the data archive also?
Yes, yes. So when we will study the asset framework, you will get to know it in details, but asset framework is actually to give a context to your process data. Okay,
Yes.
so what asset framework will exactly do, you may have seen the Pi tag list of Pi tags, right? So if you have used the Pi system management tool, that is Pi SMT we call. So if you have used the Pi system management tool, inside that, when you search for a list of tag, you will just get a list, one below another, right? It is not arranged in a proper manner. So if you search for all tag coming from a particular data source or a particular PLC or a particular OPC DCS, you will get a list of tag which is not arranged in a proper format. You will be able to sort it by name or so, but it is not arranged, right? in a proper hierarchical manner. The same thing you will be doing inside asset framework. So the same tags, the list of tags you will be having inside the data archive, you will be arranging those tags inside asset framework in a proper hierarchical manner. So what I mean to say by like hierarchical manner, so if we consider your organization at the topmost in the hierarchy, considering your organization having multiple plants and all, so starting with your organization, so in this case the TSMC will be the organization, and then the next in the hierarchy or next in the tree there will be your plant, right? So whatever you name your plant it is, right? The Schefferville plant or whatever it is. So that will be your plant, and then inside that plant again there will be areas. So areas can be divided into multiple ways. It can be divided by process, it can be divided by geographical area, so you can divide it that way, and then further you can drill down to subsection and the equipments and then the sub equipments, and you can arrange those information or those tag in a proper hierarchical manner. So if any layman come and see the information, if he want the information from your system and he don't know the like equipment ID, like instrument ID, or like what exactly, like which pump is located exactly where, or which pumps belongs to where, which fan belongs to where. So that this hierarchy will help him to identify those information. This is very basic thing, but the same hierarchy will allow you to use huge potential of the pi system and do the templatization of your analysis, your event frames, and your notifications. So that way you will be able to access your data in a proper manner. And the asset framework use by like asset framework use MS SQL server as the database. So your data archive is not storing data into the SQL server, but your asset framework, your AF database will be located inside the SQL server. Sorry. Yeah. Any question?
Okay, Animesh, I have one question.
Yeah.
Here you have written Pi interface and Pi connectors.
Right.
So what is the difference between Pi interface and Pi connectors?
Yeah, we have that slide going further, but just to say in one line. So interface are mostly generic. They will be used in a similar kind of data sources. Suppose the Pi interface for OPCDA will be used for all OPCDA. So it doesn't matter which OPC server you are using. Similar way, if you are using UFL, so it will be used for multiple file format. If you are using Pi interface for RDBMS, it will be used for multiple data sources, which is supporting the ODBC. So this way interface work. So we will go in details when we go on to the interface slides. Okay, and the connector mostly it is kind of particular for particular type of data source. So suppose the Pi connector for the Delta V, or the Pi connector for the OPC UA, or Pi connector for any other particular data source, like particular DCS, particular make and model DCS and all. So there are some more features in Pi connectors which we will discuss in next slides, next few slides. Okay, and there is one more thing, which is Pi adapters, which is basically for another type of connectivity. It has another feature and another you can say like positive things, or it can connect on, it can send data to the multiple type of databases. So that we will see further. Okay. So going forward
Okay.
to the from asset framework to asset analysis. So asset analysis enable you to do like some basic calculation. Like you can call it basic, but it has huge range of inbuilt functions available, which will enable you to do almost most of your calculations required for your reporting and all. Only if it is very critical, very complex calculation, you including major arithmetic operations, then you may need to go outside the pi asset analysis and do it in a different way. But otherwise, most of the analysis can be taken care using the pi asset analysis. Then we have event frames. So event frames are used to track the events. So what is meant by event? So event can be anything. It can be a batch. So batch can be an event. Whatever has the start and end time and a trigger point, you can consider it as an event, right? So suppose every time a new batch is started, so one event will start. Once that batch is end, so that total time period will be considered as one event frame, and then it will track all the information about that particular event. So all the information means you need to define what all parameter you want to link with that event, and then it can make it as a frame, means a start time and end time, and you can analyze that event going further. So we call this as an event frame. And using event frame, we can configure the notification. So earlier, the notification can be configured directly using conditions. Now we use most of the time event frames to configure your notification. So it can be email notification or SMS notification or any other way. If you want to send the notification, like if you are using service provider like WhatsApp or any other messaging services, so you can send the notification. Any question here?
Just one question, Animesh. Just rectify me if I am wrong. So you told for asset framework, database is MS SQL,
Right.
and for data archive we use .arc file, and we call it as Pi server.
PyArchive. Actually, that those files are called archive files, and the database is called as PyArchive. Okay. But we don't call, like we don't use the terminology Pi data archive again and again. Basically, we call it means all old user which are using Pi server for long, we refer it as a Pi server. Okay, because earlier the Pi server was only the data archive part. Now afterwards this asset framework and all other things get introduced. So new people will be referring data archive as a database. If it is very old engineers and all, they are still referring Pi server as Pi data archive. And if it is Pi asset framework server, then we call it as a Pi AF server. Okay.
Okay.
Yeah, and the data archive has its proprietary database. We call it as archive files. Okay.
Yes.
Yeah.
So sorry. Actually, I got a call. That's fine. But this so you're saying that this SQL thing, like there is no SQL involved in this Pi system.
The SQL is not involved in storing the process data.
Okay.
So major chunk of your data will be your process data, which is 1 minute, 5 seconds, 10 seconds, whatever frequency you choose. Whatever data is coming from your equipments, it is called process data, the real time or time series data. That data is not sent inside the MS SQL. That data is sent to the Pi data archive files.
So what does then the data like SQL do then? Like if all the process data is getting into data archive, then what information is coming from SQL?
Right. As I mentioned, earlier it was only historian and it was only PyData archive, because earlier, like, everyone is only uh, storing the data. They are not doing anything with that data inside the server itself. Okay. But now the system itself provide huge functionalities. So other information like asset framework, hierarchy, your metadata, then your event frames, your analysis configuration, your template configuration, all these information got stored inside SQL, because data archive format is only for the time series data. And what we are talking about is not the time series data, the metadata, the table, or your templates, your calculations. It is not the time series data, right? So
Okay, so can we frame it like that? Uh, the raw data, which is the external data, the process data, it's the data it's storing in the data archive. But apart, when it comes to Pi system, so when it comes to like handle the Pi system itself, like where is the tables and where is the meta, like analytics, how is the template designed, and so all those informations are being transferred to SQL Server.
right.
So in a way, like we need the SQL Server because the skeleton of the Pi system is designed in the SQL Server, but but the data archive, when it comes to the data storing part, like from the other data sources, so it's in the data archive, but the skeleton, the how the architecture of the Pi system it is, how you will design it, the entire thing will be, the engineering thing will be stored in our SQL Server.
Yeah, you can say kind of.
So Tapash, like I don't know if if my understanding is correct. You can just correct me. Like same as we our GR node, like we in our Wonderware. So GR is actually holding all the architecture of our Wonderware. So and so that is it is similar to that what Animesh is saying, right?
But the GR is holding the configuration.
Yeah. So here also
Here,
your Pi is
here
holding the
data archive.
configuration.
No, but here the data archive is holding all the process data, and
Huh.
asset framework is holding all the metadata.
No. Asset framework is not just holding the metadata. Asset framework is holding everything actually, including the metadata.
Yes, but not the process data.
Yes, yeah, you can access. It doesn't hold the process data, but asset framework is a method through which you will access the process data,
Yes,
the Pi
we
points.
can. Yeah, yes.
Yeah, so that asset framework is actually is a kind of a tool where we are using those where we will be using the Pi data, Pi points data, as well as the timestamp data, as well as the metadata, external data, or any other data from where like from the CSV file or from any other sources, which
Yes,
are constant, which are not changing. We are storing it in the asset framework, and we will
asset
be
framework.
using that as an analytics. Am I right, Animesh?
Yes.
So in that case, it's the same then like your like in our GR, it's holding the configuration. So here also the SQL server will be holding the entire configuration of this Pi server. Is
Pi
that
server.
correct, Animesh?
No, not entire. Actually, most of the information about the data archive is stored inside a file only. Okay.
Okay. Mm-hmm.
So uh, whatever information is there for the data archive part. Okay. So suppose your tag configuration, if you say, so tag
Mm-hmm.
configuration is not stored inside the SQL. So there will be a separate file for the tag configurations and it will be stored there. Okay. And again, so So information, basic information regarding the data archiving, it is in file format only. But when it comes to the combining data with outside information like metadata and all, and some module database information about the PyData archive, it is stored inside the SQL. So you can consider this above part, right? Part from here to here, you can consider this information is getting stored inside the SQL server,
SQL.
and,
Yes.
and some information of PyData archive getting stored inside the SQL. Okay, some configuration of PyData archive getting stored inside SQL, and all the data related or the tag related information, it is stored inside the data archive and file format.
Yeah, that's something I understood. I'm just thinking like this asset framework, the template, let's suppose, for example, forget about the data archive. This part I understood, like the data archive is not, it's nothing in the SQL. I understood because that's a huge data. We are not using the SQL. But when it comes to SQL, so you are saying this from asset framework till notification, whatever the configuration, let's suppose a template, let's suppose I have built up a template. So the configuration of that template, like how many tags will be there, and so all those things where it will be stored, the configuration of those templates.
Everything is in SQL. Everything is in SQL.
Yeah, okay. Yeah, so that's what I'm saying, like this asset framework, like the templates, the event notifications or event configurations. Hello?
Everything. Yeah, the asset framework, analysis, tables, notification, event frames, everything will be in SQL.
Okay, yeah, so all the config, even the configurations also will be stored in the SQL.
Right.
Okay, yeah, that's what I said. Yeah.
And even the PyVision. So entire detail about the PyVision and the screens will be stored inside the SQL.
Okay, and
So
including your Pi connectors, Pi interfaces, configurations, will everything will be stored in the SQL?
No. So the Pi interfaces and Pi connectors. So most of the configuration is stored like the the configuration file will be on a totally different system in this case. Okay, but the detail of the configuration will be stored in a thing called module database. Okay, so
Okay.
which actually reside in a file.
And that file will be on the same system where the Pi interface is installed.
No, so one copy, the interface copy on the Pi, like where it is installed, but the configuration details. Okay, so it is not only one. So suppose you have 10 interfaces. So all 10 interfaces configuration details will be stored inside a module database, which is a file format.
Yeah, and where that database will be there?
On Pi server.
On the Pi
that
server
means
itself.
under data archive, it comes under.
Actually, it is not data archive. So there is
no separate server called data archive.
No, so I will tell you, the data archive is the database, okay, which hold your process data, okay.
Yes.
But there are some configuration related to data archive which is in files, okay. Those are other files than data archive.
Okay.
So in for example, when you do the SQL database, right, there will be always two files. One will be the database file and there will be another file with it, right? Yeah, so that kind of thing. So data archive files will be the real-time or process data, and there will be some other files which will be holding some details about the tags and the model database and the Pi configuration.
Okay, so whenever we configure a new interface, maybe it can be like same two interfaces on the same machine, or it can be two interfaces on two different machines, but the module database of those Pi interfaces will go and reside in the Pi server then.
Right.
Okay.
Okay, any other question?
And for the Pi system, Animesh, for Pi system, Pi server, what is the minimum frequency for data collection, process data collection?
So actually, it totally depends on what data source you are using or what type of interface you are using. Okay.
Okay.
In some places, like I have sent the data like milliseconds,
Okay.
but most of the time we prefer it from 1 seconds to 1 minute kind of thing. So it varies, but so at some places we have also like collected the data on millisecond basis.
Yeah, so
Okay.
this thing I can set it on Pi interface, right? Like
Right.
when I will be setting up the Pi interface, I
Pi-
can design that.
Right.
Okay.
Okay.
Depending on like what type of interface you are using and what type of connector you are using, if it has the capability of sending data on millisecond basis.
Okay.
Yeah.
Yeah, so like Tapash, like I just want to tell you on this one, the question you asked, this Pi interface at what frequency it can take, like we have it on our Wonderware the 3 frequencies, right? The 3 scan
Three
timings.
frequency, yes. Yes.
Yeah, so here also you can configure the same 3 frequencies in the Pi interface.
Yeah, I
Like
just wanted to know that whether it has the capability to store to collect data on a millisecond basis or
yeah,
not.
yeah, it's there,
Yeah.
it's
Okay.
there.
Okay. Going forward. So once the data is available and you have formatted the data in a proper manner inside the Pi server or the Pi system. So when we refer to the Pi system contains all these components. Okay. So when we when we configure all the components and once the data is available inside the Pi system, you can like access that data in a multiple ways, right? So like we will be using some visualization tools. In your case, you will be using data link add-in like Excel add-ins to pull the data, or you will be using the Pi process book to see the real-time data or monitor the real-time data, or now the latest tool which is Pi Vision that we use. So you will be using Pi Vision to access like real-time data and the metadata both. So this is the major part which is getting used at most of the time. Then we have the integrators. So the integrators are used when it like we use by MS Power BI, like Power BI or any external uh, uh, reporting tool or analytical tool which requires the Pi data. In that case, there are some ready-made integrators available to integrate directly with the external like database or external system. Sometimes we also integrate with the SAP. So those integrators are available. So you can directly access the data from the Pi system. And then we have some system access tools. In this case, we have APIs, we have like OLDB or JDBC connectivities, like using SQL queries and all. Or you can use SDKs like Pi SDK or Pi AF SDK to pull data from the Pi system. So these are some methods that we can use to extract the data from Pi server. Any question here? Okay.
No, it's okay. We can go ahead.
Yeah.
So this line of business system is basically those other like SAP and other things, right? Other ERPs and all, MES system or any other.
So actually, not all the MES system has integrators available, but the major systems or the major components like you can consider Power BI, or there are some new systems built on top of Pi system. Nowadays, Aviva is coming with different system like Aviva Data Hub or other cloud services, which is using Pi integrators. Or you can say there is a company called Seek, which has their own platform on top of Pi system. So those kind of integrators are readily available, and you can directly connect to the that system, and the data will be available on that system to do the analysis.
Okay.
So most of the time, like Pi integrator for Power BI or SAP or Seek is getting used.
So that is Pi integrator or Pi system access?
Pi integrator. Pi system access is basically used for the custom development. Like you are using SQL queries, custom SQL queries, or API is used to pull the data. So there is custom development, right? So your system will not, like external system will not be using, or there will be no external system readily using the Pi APIs, right? So you need to do the custom development for that, and the SDKs. So SDKs will be used for the custom development. So the Pi system access is basically used for the custom development. Or if there is like company like us, we provide some mobile applications or some custom portals. So in that case, we integrate using Pi Web API and all.
Okay.
Yeah. So again, so we are doing all this stuff, but what exactly, like we have different type of user in our organization, right? But which user exactly require what information for our system, that is really the important part, and this is what we really need to think about before implementing any system. So starting from the ground, starting from the operators, what type of information really operator required, right? So though the operator will be having access to the DCS and all, but still DCS don't hold long-term data. Nowadays DCS is pretty capable of holding data for a month or two, but still if operator don't have access of that particular information on DCS, so suppose if you implement DCS, it is not implemented all over the mill, right? Some areas there will be PLCs or standalone SCADA systems and all, right? So in that case, operator should know what is happening to my equipments. So in this case, the Pi system is really important. Giving example of the another Canadian company that I work with is the AB Terrace Bay, where they don't have the DCS. The mill is quite old, around 80+ year old, and they are using still the old, we call it as a Moore controller. The company name is Moore, and the Moore controller is there, and it is so absolute that if some component like if one controller goes down, they can't buy new controller. They need to repair it or buy a refurbished controller from outside. So in these type of areas, the Pi system is really helpful. So we can integrate those like those assets, those controllers or the PLCs, the standalone equipments, and then we can get that information available for the operators. So all the real-time information about the assets and equipments will be available for the operators. Then we go to the maintenance staff. So maintenance staffs need to know what is happening. So not necessarily every time when there is a failover and then only, or the breakdown, then only the maintenance team should go. Maintenance team should have access to all the information, all the critical assets real time, so they will be able to get hold of any situation before getting worse, right? So before breakdown, your asset always give you signals, so you need to track all those signals, and you need to keep eye on those kind of events to do the preventive maintenance and all. So maintenance team will also need their type of information to improve the maintenance work or prevent the breakdowns and all. Then going to the process team, right? So process team will need all the information regarding the current running situation and the maintenance situation and all. So process team don't sit inside the control room, right? They will be inside the office or inside the IT network, you can say, and all your equipment will be inside the plant network or the OT network, we call it in the IT term. So to get the information from the ground level to the IT network, the PI system is really useful. So like process team or the process manager or any planning team, production planning team will have the access to the real-time data. So they will be able to do the process or production planning in a proper way. Then it comes to the analytical part. So a team which will be analyzing the daily production thing, doing the reporting part and all, they will also be needing their type of data. So they really don't need the granular process related information, right? They will be needing the cumulative information like daily average, hourly average, or the daily production, shift wise production kind of thing. So those type of information will be available for the analytical team, or the, you can say, the higher management, right? Because in the end these kind of reports goes to the higher management. So these are the different kind of information that we can collect using the PI system for all sort of users. So it is not only for the one type of user, it is from the bottom, from the PLCs to the higher management, right? So all type of information, even you can combine your production planning information, your budget information and all together inside the PI system and make a good you can say dashboard out of all this information. Any question here?
No, that's okay.
So again, these are the KPIs that we will be looking for, right? In any industry, these are the major areas that we really want to look like to monitor the asset health, if the asset is performing properly, if the maintenance is done, all right. Then the process optimization, where we really track what is going wrong, why the production rate is low and all, and then do some analysis on those kind of information and optimize the process, get better yield and all. Then the quality tracking, we also integrate with the lab equipments and all to get the quality information from the lab equipments and combine it with the batches. So and define a golden batch, define a base parameters and all. That kind of thing can be done using the quality tracking and all. And obviously the major expenditure that every industry has is the utility area, right? So your water or your electricity and all, you need to track the consumption, and you need to like track how much you are spending. We also do some external integration with the prediction data, right? In Canada, you have some power price prediction available on website. So we integrate it with that data and do some energy efficiency calculation and all. So when as and when the price goes up in the market, our client reduce the so grid intake, and it produce like so they have their own diesel power plant, right? So they produce their power by themselves in that kind of thing. So you can just track the consumption of utility and energy efficiency and all. Then the regulatory compliances, like every company has, they need to track the uh, all the parameters of their uh, like production and all. And in that area also, you can just track all the information and do the reporting. Same with the safety and security. So we also track some environment related parameters from outside equipments which is located around the mill or inside the town. So we also collect that kind of information and get it available for the authorities and the local analysis team. Going forward, so these are the industries, like almost all the industries are using pi system because it is a very robust tool and it has a huge potential, comes with multiple features and functionalities, and a huge opportunity to integrate almost all sort of data inside of one location. So these are the industries that we work with. Just a minute, I will just have some water. So this is the main reason why nowadays everyone is going towards the Pi system or any other MES system, because most of the time all of your information or all of your data is scattered and it is in silos. So though the data is related to each other, but you cannot really get hold of all the information at one place and do the analysis or do the decisions using that information, because it is available in silo and it is very tough job to get all the information at one place and arrange it in proper manner, so a proper decision making can be done. So as you can see here, we have the process related data, then we have the lab integration data, we have some equipments which is not connected to any other control systems. So we can put a separate like sensors and gateways on that. So all this information is scattered right now. So uh, to get it in one place, the Pi system is the perfect tool we have. So because we have huge number of interfaces and integrators, connectors available here. So this is how the Pi system works, right? So it doesn't matter if it is a database or if it is an instrument or it is a controller or any other data source. In this case, if it is a file format, so data is available in CSV. Sometimes we also write a small code to collect data from the lab equipments, which only has a serial port available, kind of thing. So that kind of information can also be collected and then stored inside the Pi system, and obviously do the enhancement means do some analysis using that information, tracking the events or getting some value out of it, and then deliver the information in different ways to different uh, stakeholders uh, as per their requirements. Any question here? Okay.
No, I'm good. Thanks.
Yeah. So this is a bit project management kind of part, but this
Hello.
is
Animesh, I have one question.
yeah.
So whenever you come across a instrument from where you want to take data, and you find there is no ready-made integrator or any kind of software is there to take the data, so that in that point you do your own scripting to take data from that instrument, or how
Yeah,
you
sometimes,
manage that?
sometimes. Though 99% of time you will be having the integrator connector or sorry, the interfaces connector or adapters available, but sometimes the equipment will be too old or the equipment will not support that particular application. In this case, we may need to write some application. So I myself has written some code like .NET code and all to collect data from the serial ports and all. So
Okay.
yeah, sometime you need to do that.
Okay.
Because though the system is built considering all the possibilities, but you know, right? It is a huge world and everywhere someone is building something new. So not necessarily it will support your system. Uh,
Yes.
so Pi has given all sort of uh, mechanism to connect or like send data or to pull the data from Pi system. So you can use all those mechanisms in a different way to either push the data into Pi system or pull data from Pi system. So that is the very good thing of Pi system. So it is not only because I am working on Pi system, I am praising the Pi system, but I have also seen other historians or other databases where it is really restricted. So in Pi system, that is not the case. You say any type of digital information, you can push into the Pi system one way or other. So that is the good part. And same with the pulling data from the Pi system.
Okay.
Yeah. So coming on to the planning, this is kind of project management part, but this is really important because we have struggled with a lot of clients in this side. Like though we are ready with the implementation plan and all, but it is always very tough to work with the plant people or the site people to do a successful implementation of our project because as you see right just 3-4 slide back, so it is not only one section or one type of user that we will be having, right? So we will be dealing with from the operator till the CXO level. So everyone has their own requirements, everyone has their own suggestions and all. So in this case, you really need to do a good planning to do any kind of implementation. Otherwise, you will just end up doing work for one set of people, and then you need to do a multiple iteration for the same thing, or you may need to do a lot of correction um, for just a small type of thing that you need to do, right? So when we do the implementation at any place, what we suggest our client, so though it is very good to get a big project at one go, so we get a good amount for one project, we suggest going with a small chunk, keeping the requirements simple, uh, just noting down a good use case, right? So in this case, just noting down couple of outcomes that you want, so initial outcomes that you want from your project. So in some case, like in most of the cases, the very first thing that is required is uh, data collection. So the very first outcome that you can just think about is data collection part. All the data is available in one place, and then the next part is the building the dashboard or remote monitoring. Then again, once the data is available inside the system, then you do some basic analysis and then make that properly massaged data for the data scientists. You really don't want to give all sort of garbage data to the data scientists, right? They really don't want to do all that filtering part. So that kind of filtering you can do inside Pi system itself, and then provide that data to the analytical team, right? And then again, you might be having other objectives like replacing the old reporting system or any other system like lab management system or any other. Sometime we have also replaced the energy management system here. So that kind of project goals you can set one by one on a small chunks, and then you can just go forward with that part of implementation. So once you do first part of implementation, most of the people will get to know what exactly is the capability of the system, and then they will come with more ideas, complex uh, kind of calculations and all. And at that time you will have a bigger picture that okay, now you will be able to do a whole lot of things, and then from the starting you start developing your template that way. So you will be able to take care of all those requirements once the entire system is implemented. Sometime what happen, we do the implementation of entire system, so initial input comes from the ground level people only. So once we do the implementation, then the higher management get look of that in system, and then the requirement starts coming. And then again, because there will be a huge changes in the requirement, we may need to change all the templates, we may need to change all the hierarchy and all in that uh, that matter. So we always suggest to go like in small chunks and all, and then again doing the proper charting, like how you really want to do the implementation of your Pi system. So what I mean by the proper planning? So sometimes it is not only the local Pi system that you will be implementing, right? In most of the cases, in big clients, they will be having multiple Pi servers. So some servers will be on the site location, and then there will be one server at the central location, and then there will be one server at the headquarter location. So this is mostly in the case of oil and gas, because you will be having a refinery, right? One offshore, one like offshore oil, like you say it upstream, right? When you extract the oil from the ground or from the sea and all, so you will be having your oil wells and all. So at that place, you will be having a separate Pi server, so you get hold of all the information of the process data. Then so oil wells, or the we call as a well pad, or one area of oil wells. So there will be multiple areas of such kind of oil wells. So then there will be a central Pi server for all that area, and all those local Pi server will be sending data to the central Pi server in this case. And then once the data is available on the central Pi server, some analysis will be done and all. And at some places, they will be having a corporate asset framework installed separately. So that way you should plan your implementation. So this is the reason I have kept this point here. And again, define the success. So this is totally the project management part, but I really want to mention it because once you will start implementing, you will face this kind of issue, because initially when you will go to each and everyone and you will ask their inputs, what you exactly need, they will not give you information for sure. for sure when you will start the implementation, you will not be having any inputs. But once people will start seeing the outcome, then they will start getting the more ideas, and then they will just keep chasing you that okay, I need this, I need that, and all. So that is the reason.
Yeah, once you show them something, then the real inputs will come.
Right. And it is not that case only. Like we have suffered a lot. Like sometimes the requirement will be sensible, right? So okay, this information is not available, or these calculations need to be done. This raw data is not useful. I need a proper trend here. I need a comparison, a standard deviation chart, and kind of thing. So these kind of inputs are still sensible, and you will be able to incorporate that easily. But we have seen such kind of like, I don't like this font, I don't like this font color, this background is not good, this color is not like, or you just need to shift this from here to there. So these kind of requirement is really means sometimes we fed up because of these kind of requirements. So you will see that on the go, like once you will start the implementation. So
Yes.
you will really see that. So again, you need to, as I said, you really need to take the consideration of all the stakeholders, right? Because all the
Right.
stakeholders will impact negatively or positively. Because once you will start the implementation, there will be always some guy who will be the obstacle for your implementation. So one way or other, he will be searching for the flaws in your implementation, the way it is not good, it is not useful, or anyway, right? So those kind of people will also
Right.
be there, and there will be some kind of people who will be really supporting you in this implementation, and there will be some people who will influence your uh, like implementation, right? Their opinion will really matter, and you really need to change your implementation that way, right?
Right.
So as you can see, so if there are too many stakeholder, then the decision making will be slow. So some will say this, some will say that, and you will always struggle with the final decision. And if there are too few people, like I said initially, if you only get the input from the base people like the operators and all, then there is risk of progress, because they will not be having that kind of vision, right? They
Right.
will only be having the vision of their area, like okay, I only need this information or that information and all, but they will not be having that broader vision of what all the system can do and what all you can get out of the system. So that way you need to identify, or you need to balance, and you need to take all the stakeholders in the consideration in this case. So there will be some decision makers, then there will be some check signers, influencer, and opponents. So actually this opponent part we have faced a lot, because sometimes the project is driven by the plant people, and sometimes it is driven by the head office, right? So
Right.
when it is driven by the plant people, then once you do the implementation, the head office will always ask the question why it is not going this way, or why I am not getting this, why I am not getting that. But still it is okay. But if you come from the head office, if the project is awarded by the head office, you really struggle getting help from the plant people. At the end you will be doing the implementation at the plant level, right? And you really need the support from the plant people in this case. But if the project is driven by the head office, the plant people will always oppose you. So when we will be when we were doing the lab integration project, people are very reluctant, because they really don't want to share all those information of the uh, lab, because they used to manipulate the values, they used to manipulate the outputs and all, they used to change the values. So they really don't want to go the crew information to the HO. So they were really very reluctant. So what was the 15 or 20 days project? It took us 6 months to implement because we were not getting proper support from them. So it always happens. So you really need to take care of that. Okay. Coming back to the Pi server here. Any question? Need break for 5 minutes?
No, we can continue.
Okay. So yeah, coming to the Pi architecture. Okay. So starting with the data source. So in this case, I have considered DCS as a data source. So once you have your data source and the data is available at data source, the very first component that receive the data from data source is a interface or a connector that we see, right? And when we implement an interface, so interface is not a single component which will be working on that system. Sometimes the OPC server and the interface node are two different machines, and sometimes you install the interface on OPC server itself.
So Animesh, all these interfaces are only software. There is no hardware interface.
Okay. So when I refer to the interface, it is a software. But when I refer as an interface node, then I will be referring to the machine where the interface is installed. Okay.
Okay.
So in this case, when I refer to the interface, it is always the software, and Pi, like Aviva Pi, only supplies the software part. They never supply or they don't deal in the hardware part. Okay. So hardware part always we need to take care of. So sometimes it is the client who take care of all the hardware, or sometimes client want to give like entire project, then we take care of hardware. But most of the time the networking part, because the networking is very crucial and the plant people know is it better, we supply the servers, we supply the interface nodes or any other machines, the firewalls and all. But the networking part, 99% of time is taken care by the client IT team, because it is not, this is not the only server that will be affected because of networking, right? So networking part is all, yeah.
So whenever you are saying interface, it's a software, and
Right.
whenever you are saying a interface node, that means it's a physical server or
Yeah,
some system.
physical machine, right?
Okay.
So one
Got it.
interface node can hold multiple interfaces. In your case also, as I can see, you have 4 interface node installed right now, right?
No, actually, what we did is Animesh, that has been changed now. So when you did it at that time is in a single machine, we had created multiple interfaces, right? When you were there. So yeah, so now that structure has been changed. So we have created 4 separate nodes now, like 4 separate or like OFS server, or you can say Pi nodes. And each of those Pi nodes are having multiple Pi interfaces. Like depending upon when I say Pi interfaces, so for me it's an OFS server, like it's one of the PLCs.
Right. So
Right. So yeah,
right.
so there are we have distributed the load now. So like there are 4 Pi interfaces, 4 Pi nodes now, and on each node there are multiple Pi interfaces present.
Right. So we call it as a multiple Pi interface instance. Okay.
Yeah, instance. That's right. Yeah.
So now, if the OPC server and the interface instance or the interface application is on the same server, then you can just connect to the OPC directly using OPC client. So you really don't need to do much configuration in this case, and you can start collecting data in interface or OPC client. Okay, but if the OPC server and the interface node is on different systems, in this case you need to do the DCOM configuration or DCOM setting. Are you aware about the DCOM settings?
Yeah,
You
a
can
little bit
tell.
knowledge on DCOM settings. Whenever we do PLC to server SCADA to SCADA communication, that time we need to do some DCOM setting, but not a much idea on that.
Yeah, no, it is just a basic DCOM setting. You need to make sure that in OPC enum on the both side you allow uh, that particular user which is running the interface, uh, like it has the access on the OPC server also, and the interface node also, the admin access or the access to the data. So you just need to make sure that in the DCOM setting there are few configuration. I have the DCOM setting file with me, so I will be sharing that with you. So that kind of simple DCOM setting you need to do in that case. Okay.
So this DCOM setting should be between OPC server and my Pi interface, Pi node, right?
Right. If it is on different machine.
Yeah.
If it is on same machine, so no DCOM is required. DCOM is basically distributed communication thing. So if it is on the same system, you don't need the DCOM.
So tell me one thing, Animesh, this Pi node, let's suppose in a Pi node, there are multiple Pi interfaces or Pi instances available, interfaces instances available, and those instances are referring to different Pi servers. It's possible, right?
Yes, it is possible.
So because it's not like what should I say? Like it's possible that let's suppose I have different Pi servers in like for different PLCs in like different not Pi servers, sorry, different OPC servers, and they are on different machines. Now I have only, let's suppose I have only one Pi node. In that Pi node, I am trying to get all the 4 instances, or like for those OPC servers in the same Pi node. So in that case, will the DCOM setting will be same or it will be different?
Look, so in DCOM setting, basically what you do in DCOM setting, you just allow that particular user to communicate with your OPC server. Okay.
Yeah.
And collect the data, make groups. It means create groups of tags, then pull the data from the OPC server and just means collect it on this system. So from the OPC server to your interface system. So if there is a multiple OPC server, you just need to do the same DCOM setting on all those OPC server. Okay. What is meant by same DCOM setting? There is a defined user, so you need to give access to those user on all those OPC servers.
Okay. And what about the is there any setting that we have to do on the Pi interface or the Pi node?
So on the Pi node, look, so not necessarily all your 4 or 5 OPC will be having same user. Okay. So mostly what we suggest, let me draw it for you. Okay. So what we suggest is, suppose this is your OPC 1, right? This is 2, this is 3, this is 4. Okay. Now, if you talk about the user, This might be your user 1, right? This name will be different.
Yeah.
Okay, so we'll say add user A. Okay. Then here, suppose it is same user A. Here it is user B. Because if you have ABB same system, then
Yeah, that's fine. Yeah.
yeah, so it is kind of thing. So the users. So now you have 3 users. Okay. So to communicate from here to here, the condition is at both sides you should have same user with the same password.
Okay.
Okay. So here is your interface node. Okay. And then on this interface node, you need to create all these 3 users. Okay.
So where will I create? In the Pi node? This is a Pi node where you are doing it right now, right?
I will,
So this Pi node will have 4 different instances now.
right. So now there are 4 different instances, right?
Yeah.
But these 2 OPC are with same user, this with another, this with. So now, if you want to communicate with these 2 OPC, you will be using this user. Okay, because the condition is at the both side, you should have the same user with the same password.
Okay.
Okay, same here. This will be communicating to this. This will be communicating to this. Okay. Now, what we do most of the time, we just create one user called Pi user. Okay, suppose. Okay. If the OEM allows, we create this same user on all these OPCs with the restricted access, because you really don't want these users to mess with your OPC, right?
Yeah.
And because these users are already created, they will be having some extra privileges on. So what we suggest is create one user here, and if possible, create same user on all these OPCs with restricted access, like read-only access to the OPC server. Okay, so this is the way we do most of the time. Sometimes OEM don't allow us to create new user, so we need to create same user on the interface node. That is the only difference. But now you will be doing the decom here also, here also, here also, and here also on all these OPCs. You will be doing decom on this system also. The difference is most of the decom setting will remain same. At the time you will add a new OPC server, you only need to add that particular user in decom setting for that OPC. Understand? Or should I repeat?
Yeah. No, that's fine. Well, like
Okay.
we'll see to it when we will create the Pi interface. At that time, we'll see, because right now I understand what you are saying, but once I see that where the users are getting created at that time, where we are mentioning those users as well as with their passwords, that time you just repeat that point over there, because right now it's all like we are going on an overview, right?
Right.
So, Animesh, during practical, you will show us how to make decom settings and all these things.
Actually, I don't have any OPC, but yeah, I will guide you from my side, means in the server side. I will try to install one OPC component, but I'm not sure uh, if the decom setting will be possible. But yeah,
No, what we can do is, Animesh, you can try over there as well, like whatever you are saying, we can do that. But we have all the systems over here. I can take those systems in remote, and you can just show us that what all things needs to be changed, and because those are already done. So, but you can just mention us that this is our. I will just open one of our OPCs, and we can go go inside that, open the DCOM settings, and you can mention that these all things needs to be changed on this side, and on the Pi interface side this needs to be checked. So those things you can just show us. You can
Sure.
tell us.
Sure, no problem. So it is not that difficult actually, but yeah, I can show you. No issue. Okay, going back here now. So suppose the OPC on the same system, we don't need the DCOM. If OPC on the another system, we need DCOM. Okay, that is the only difference here. Now, inside the interface, we will be having two major components of the interface. Okay, one is the interface instance itself. This is the OPC server. Okay, so just so the data is available in OPC server, so we are considering that. So once we install the interface, so there will be an interface here. The utility that we use to configure interface is called PyICU, Pi Interface Configuration Utility. Okay, and this will be the executable for the OPC, like Pi OPC DA or UA, whatever you are using, or HDA. So I am considering the basic Pi OPC DA here, which is most of the time you must be doing. So we will be having one instance of OPC DA interface here, and then we will be having Pi buffer subsystem. Okay. So whatever configuration we will do to collect data from OPC server, that will be done inside this OPC DA configuration. So here we will do the connectivity on the both side. So one connectivity will be to the OPC side to collect the information, and the second connectivity will be with the Pi server to push that data into the Pi server. But the data will not go directly to the Pi server if you have considered the buffer. Okay, so you may have heard about the buffer, right? So what exactly Pi buffer do? So in the case of, if suppose your connectivity between the interface node and the server is broken. Okay, so this is your Pi server. So suppose this connectivity is broken. In that case, to prevent the data loss, what Pi buffer do is collect the data from the OPC and store it in a buffer file. We called it as a buffer queue. Okay, so whatever information it is coming, like if it is 5 seconds or if it is 10 seconds or whatever it is, the information will be collected from the OPC, because of OPC don't hold the information, right? You may be aware about that. The OPC don't hold the information. So as and when the value change inside the DCS, OPC will show that current value here. We don't store the past values. So to prevent the data loss, because like the interface will only pull the current value available on the OPC. So in this case, what you will do, the OPC interface will pull the information from the OPC server. It will send it to the buffer subsystem. And if the connectivity is lost, buffer subsystem will store the data till this connectivity get established. So you will not have any data loss because of the network issue. So if you consider buffer, then and then only the data will flow through buffer to the Pi server. If the buffer is not enabled and the connectivity is lost, then you will lose the data for that time period. The buffer only works in the case of the connectivity loss between the Pi interface and the Pi server. If the connectivity is lost between the interface and data source, you will lose the data anyway. So there is no option, because data needs to come at least till the interface to buffer it. If data don't come to the interface itself, you will lose that data. Any question here?
Yeah, so
Yes.
yeah, go ahead, Tapas.
Oh, yeah, Animesh, that Pi buffer has no time limitation. That means, let's say, between the interface and server, we lost the communication for 1 day, and after that, when the communication re-established, all previous day data will come to the Pi server, or it has that buffer has some limitation of time.
So buffer has the limitation of the time, but it is totally depend on the size of available disk space.
Okay.
Okay. So if you have, suppose you are collecting 10,000 tags, okay?
Yes.
And the frequency is every 10 minutes or so.
Yes.
And you have around 10 GB of disk space available on your interface.
Yes.
So you can consider that 10 GB of space can hold 1 month at least, like it is minimum, it is way beyond that, but it can
Yes.
hold at least 1 month of data for those 10,000 tags. So though the network don't get established for 1 month, you will not lose your data.
Okay.
So is there any kind of data compression happening?
Yes. So that data flow I will explain you in upcoming lectures. But yeah, the compression and exception mechanism comes from here itself. Okay.
Okay,
So,
and how the data flow is done? Like, is it through the buffer, or is it only during disconnection it stores the data in the buffer?
it always flow through the buffer if the buffer is configured.
Okay, so the data always flow through the buffer. So the data
Yes.
first reaches the buffer and then it reaches the archive.
Right.
Understood. Understood. And can we set up? Is there any like redundancy thing, like Pi interface redundancy as well as the server redundancy? Can we set up this as well?
Yes, yes, it is in next slide, so I will just explain it that time. Okay.
Okay.
Yeah. So once the data is inside the OPC, interface will collect the data, and then it will send the data from the Pi buffer subsystem to the Pi server. Okay. In this case, what I have considered, just don't consider this part, the Pi collective. I forgot to delete it. Okay. So this is our Pi server, and Pi server means it has the Pi data archive and the AF server. Okay. So AF server means right now I am considering only one server for all the Pi components. Okay. So whatever Pi components we have seen in previous slides. Okay. So for all these components, I am considering only one server hardware. Okay. Or one server instance. So from Pi server, data will come to the Pi data archive. So Pi data archive will store that data, and then that data will be accessible inside the AF once you configure your asset framework and all. Okay. Then you will be, like, for the asset framework, you need an SQL server, right? So there are two ways. If it is very small server like 1000 tags and all, what we do, we put all the components on one server itself. So Pi data archive, Pi AF, SQL server, So we put everything on one system because it is only 1000 tag system. So you really don't need those like that much of resources like RAM and all processor. So we put it in single system. But for the AF, you need an SQL server, so which holds your PyFD. So a PyFD is actually the AF database. Okay. So whenever you will see the PyFD database inside the SQL server, that means it is an AF database. Okay. Then like whatever configuration you will do here in AF, it will be stored inside the PyFD. So you can keep this server separate or you can keep it on one server. Then you do the visualization part. So you can just install the PyVision on the separate server, and the PyVision actually communicate with the SQL server because all the configuration is stored inside the SQL server in this Vision database. Okay, but whatever data will come, because it is only holding the configuration of screens and other information related to the user access, the authentication and all. But all the information, all the data will be coming from the PyData archive and the AF server. From AF server, you can just put the metadata and all, and even the tag configuration means the tags you can map from AF server, but whatever data will come for those tags will come from the PyData archive to the PyVision screens.
So how come? Yeah. So I understood like this for the PyVision, it will access all the Pi data points, like all the Pi points it will take from data archive, and all the AF points it will take from AF server. Okay.
You're right.
But what information it is getting from the SQL server?
All the configuration, whatever a screen will be designed, no? So the
Okay,
symbol,
the hierarchy. You mean to say the hierarchy?
even the screen configuration. So suppose I design a screen, right?
Okay.
Let me check if I have one. So suppose this screen is designed, right?
Mm-hmm.
So whatever is designed, so this screen is getting stored inside the database only.
Okay. Okay.
This instance of this screen. So whatever I have, this chart I have done, this gauge I have done, this letter I have done, and whatever mapping I have done. So though the value is here, but I have mapped this value with the tag, right?
Mm-hmm.
So all this configuration is getting stored inside the this Vision database.
That is inside the asset framework.
No.
Asset framework server.
SQL server. No, that is
No.
in the SQL server.
This is SQL server. So
SQL
SQL server will be holding two databases. One is PyFD, which is AF database, and second is the Vision, which is PyVision database.
So let's suppose if we have because this PyVision is a server like it's a web server, right?
Yeah.
So anybody who is accessing this web server, any client, if anybody is accessing, so all the request will go to SQL server then.
Not really, because again, SQL server will only hold the configuration part. So suppose I click on the screen, it will only load the configuration of that screen from here. And whenever you will double click on any of the parameter, it will give the call either to AF or the DA, because you will be able to map
getting the data.
You will be able to map PyTag directly also and through AF also.
Yeah, so that is understood. Like when you map it, when you let's suppose I have designed a PyVision a page for myself. Okay, so that when I designed that page, the configuration of that page, let's suppose I have 5 trends, I have one equipment and everything, all the equipment data, level data, whatever it is. So all those configurations are residing on my SQL server, right?
Right.
And when it comes to getting the data, it goes to my Pi server to get that it looks at that tag and it goes to Pi server to fetch that data.
Right, absolutely.
Right? So my question is not that. I understood that part. My question is, let's suppose it's a Pi Vision is a web server, right? So when
Yeah.
it comes to Pi process book, I understood like that is something, a tool is there which is sitting in my machine, and it is when I configure that configuration is again sitting. I don't know where it is sitting, but for me it's sitting on my, if I'm saving it, then it's sitting on my same local machine, and when I open it, when I refresh it, it goes to my Pi server, fetches the data, and then it updates the data. But when
Yeah.
it comes to web server, so that means I'm requesting as a client, I'm giving a request. So that web request, like HTTP request, has to go somewhere from where the response should come in. So, and which is sending me all the configurations of the of that particular page. So where does it go? That is my question.
Right, right. So this web application will be installed on your server using IIS. Okay.
Which
So
server?
Pi Vision server means there will be a separate machine, right?
Okay, so apart from all these, there will be another machine where I will be configuring that IIS server.
So in our case, the DCS is one thing, then the
Mm-hmm.
interface node is another machine, your
Mm-hmm.
Pi server is another machine, and
Mm-hmm.
your Pi Vision is another machine.
Okay.
And in this case, I have considered SQL server as a separate machine.
Okay.
Else, you can just keep it on the Pi server.
No, let it be. Let my SQL server be a separate machine. Let
Right.
it be there. So
Now,
when you tell the IIS server,
we
where
have
does it sit?
your Pi Vision installed on a separate machine using IIS. Okay.
Okay.
So when you hit the URL, it will call the IIS. Okay.
Mm-hmm.
And then whenever you will open a page, it will pull that information from this database, Pi Vision database, through IIS itself. And
Okay.
then
Okay. Okay.
once you click on any uh, tag or something, it will call the this data archive or AF server.
Okay. So I was thinking this Pi Vision as a client machine. So it's not a client.
No, it is
It's the
server.
IIS server. Okay,
Yeah.
that's the IIS server. So so when it's the server configuration is there, but for getting all the configuration of that particular URL, all the URL's configuration is sitting again on the SQL Server Vision.
Right.
Ah, understood. Okay. Okay.
Any other question?
No, I'm good.
Okay, just give me 2 minutes. I will just stretch my legs.
Yeah. Yeah. Sure.
Yeah. Okay. So going towards your last question about the redundancy part. Okay.
Yeah.
Again, so as we know, Pi system has multiple components, right? And I have only shown you a simple Pi system here, like everything on a same server, right?
Yeah.
Which is not the case most of the time. It is only the
Which is
case.
not the case.
Yeah, which is not the case most of the time. It is only the case when it is a small, simple Pi system, what we call a small Pi system with 1000 tags and all. Otherwise, this AF server will be on a separate system, and like that is the only major part, major difference is there. Like the AF system will be separated, because if your system, like Pi system, has more than 5000 or 10,000 tags, then you really don't want to share those resources, your like system resources like processors, RAMs and all, because your AF server will be doing the calculation part, right? And it will be almost every second. If you have 10,000 tags, then you may end up doing 1,000 odd calculations, which will be either like time trigger or either event trigger. So as and when the value will come inside the Pi system, it will trigger the calculation. It may be doing the notification part, it may be tracking the events. So it will be doing multiple things, right? So you really don't want to share the resources between the data archive and AF. So because you will also be pulling the data from data archive, right? So it will affect the performance of your system, so you will not get data quickly. It will take time to load the data in uh, a PyVision trend or in data link report. So you really don't want that. So what we do, we just separate the AF server from the Pi server, like Pi data archive, which I will be showing. Okay, so here you have one DCS system, suppose, and then what we do, we configure the interface redundancy. We called it interface failover. Okay, so what we exactly do, we configure failover at two different level in interface itself. One we call as interface level failover, and second we called like OPC server level failover. So when we talk about the interface level failover, what we really do is, as you can see here, so each interface is pointing to one OPC server. In this case, we have redundant OPC server for one DCS. So both the OPC server having same data in them, and my one interface instance is pointing to one OPC server, and another interface instance is pointing to another OPC server. So here what we do the identical configuration of these interface instance, and we configure them for the interface level failover. So why I'm just stretching this word interface level failover is, if like this interface goes down, then the another interface start collecting the data from the OPC server. If there is no redundancy of OPC system, OPC server, then there is a possibility that both the interface are pointing to a same OPC server. In this case, the OPC server may be on one of the system or maybe outside of the system on a separate server. But when we configure the OPC interface level failover, once one interface goes down, another interface, which is a backup interface, start collecting and sending data to the PI server. And to do that, we configured the UniInt failover, which is a type of configuration which create a file on one of the system. So it's your call where you want to keep this UniInt failover file. So you don't keep it on both the system. You keep it on any of the system. It's your call. And this failover information will be stored inside this file. That means this interface knows what is its counterpart. So they will be sharing the information in between, information like the health information of the interface. If the interface is running properly, if it is connecting to the OPC server or not, if it is getting good data or not, right? Or if the interface service is down. So that kind of information they are sharing in between. So once like there are multiple conditions, suppose the interface service get interrupted. So this interface will get to know and it will start collecting and sending data to the PI server. Else, if this interface node connection with the OPC is like broken, suppose this OPC is outside, or this OPC is not collecting the data, so the values are not good. So in this case again, this OPC interface will get to know and it will start collecting data and sending it to the PI system. Any question till here?
What's the full form of that UFO?
It is UniInt failover.
Unique failover.
UniInt failover.
UniInt failover.
UniInt, right?
So UNIENT.
No, UNIINT.
UniInt.
Okay. UNIENT.
So Animesh, so you said like these two are like actually they two are acting as a redundant, right? Like one to each other. So one is primary, one is secondary, and that UFO file is deciding which one is active right now and which one is it standby. And in case of a failover, the other one becomes standby, and the one which is active becomes the primary, right?
Right.
So it's all like you in the UFO file, that file configuration can be done anywhere in between the two interfaces, or it can be done outside of these interfaces as well.
No, it should be done on one of the interfaces.
Okay, and that's a different service, or it's a different installation you have to do for this UFO?
File. It get created automatically. It will only ask you for the path.
Okay, got it. So and this OPC servers, so is it mandatory that both these OPC servers have to be identical? Can it not be different?
What is mean by different?
Because this OPC server, because what we generally do is like we create redundant OPCs like OPC server 1 and OPC server 2. So we create the same instance on OPC server 1 also, we create the same instance on OPC server 2 also, so that in case of any failure, the other one will come up.
Right. So that is the second type of failover. So that is what I'm about to explain. So I explained you the interface level failover now, right?
Yeah. So no, if you go to the previous slide, so if that's not the case, if in that one which you are explaining, so in that case both the OPC servers have to be the same.
Not have to be. I am considering it as the same.
Because when you configure the OPC interface, so in that case you have to mention some node ID, right?
Right. Now listen.
So in that,
right now, in this particular case, these two are the separate server. Okay.
Okay.
and the redundant server. Okay. The way you
Okay.
are telling me that you configure 2 server redundant for the OPC, right?
Okay. Yeah.
Right. So in this case, the case I am explaining right now, it is the case where there are 2 redundant OPC server. Okay.
Okay.
But I am not configuring the interface failover on OPC failover. Okay. I am configuring it interface level failover, not OPC level failover right now. What I have explained. Okay. Right now, what I did, if one OPC, one interface goes down, another take place, but this interface is collecting data from this OPC and this interface collecting data from this OPC, though the data is identical. Okay.
Okay. Okay. So the OPC, yeah. So definitely, if these OPC servers are different, so when you configure the OPC int, so in that case, your the ID will also be different, right? For
Right.
because it's a different. Yeah.
Right.
Got it.
Right.
Mhm.
Now, because this is interface level failover,
Mhm.
I am only considering that once this interface goes down, this will take up. Yeah, Tapash, do you have any questions?
Yeah, in this case, what will be the condition of pi buffer?
Yeah, so pi buffer condition will be the same. If this is primary, so the green one is primary for now. Okay, why I'm
Okay.
drawn is at a green, because I am considering this as a primary. Okay,
Okay.
so it is like collecting data from OPC, sending it to the buffer, and then it will go to the Pi server.
Yes.
And this is on standby. This is not sending any data. But
Yeah, let's say the first OPC interface get disconnected. Then the second OPC interface will be active that time.
yeah, right. So second will
And
be
what?
active.
Yes, second will be active, and that time what will be the status of the pi buffer? That second pi buffer don't have the value of the previous data. Previous.
Right. But as it is communicating, right?
Okay.
The time it will go down, both the OPC will be having same information in it, and it will start sending data through buffer. Okay.
Okay.
Here
Okay.
there is a possibility, because there are multiple type of failover that I will explain you when we will start the interface configuration. Okay. There is
Okay.
cold failover, there is warm failover. There are 3 different type of warm failover, and there is a hot failover. Okay.
Okay.
Okay, so this pi buffer, like in case of a redundancy, the pi buffer will like the role of pi buffer will be nothing in case of this failover, right? Because if let's suppose pi int the top the primary fails, it is going to switch on to the secondary, and the data is going to archive. The pi data archive won't understand, the pi server won't understand that there is a failure in my pi interface. Even if it understands, it will not lose any data. But in the meanwhile, as your pi inter the top one has failed, so it will start storing the data in the pi buffer, right?
Right. Right.
So
So
yeah.
again, this if this is failed, so this buffer will be empty because it has already sent the data and data is not coming in it. Okay. But there are, as I said, there are 3 different type of failover. In some failover, you may lose data for few seconds. Okay, because the procedure is, once this interface get to know that this interface is down, it is a second or two.
No, that part I understood, Animesh. Like that the time between the switchover, that part of the data we are going to lose if considering that OPC servers are having the same amount of data, like same flow of data.
Right.
But my question is, when it switches to the secondary, all the data, ultimately our purpose is to send the data to the Pi server, right?
Right.
It can be through any source, that primary or the secondary. So in case of when it switches, so through the secondary, it will start sending the data. In the meanwhile, when the primary is failed, like in the meanwhile, when the like after the switchover, the instance which has failed, it will what will happen in that case? The pi buffer. Initially, it will be empty because your pi interface has failed. But when it will come up, will it start storing the information in the pi buffer?
Yeah, actually it holds the information. Means what happened? It totally depend on your bandwidth. Okay, so it is depending on the bandwidth between your interface and your Pi server. So if you are collecting thousands of value, like 10,000 value at the same time, which we really don't like, we don't ask, like we don't suggest our client to do it that way. We keep offset. So suppose one interface is collecting 5,000 tags, we tell them that okay, though it is the same frequency, 10 second, 10 second, 10 seconds, but you keep 1 or 2 second offsets, so it will only send 1,000 tags at a time. Okay, so though it is a 10 second frequency, but it will only send the 1,000 tags at a time. So what buffer do is buffer collect the data continuously and it continuously send the data to Pi server. So it is not like buffer is holding it for a minute or so. The time it comes into the buffer, and if the connection is available to the Pi server, at the same time buffer will send the data to the Pi server. Okay, so once it is collected, suppose the primary is collecting value right now, the time data will come into the Pi buffer, it will immediately send it to the Pi server if the connectivity is available. Okay.
Yeah.
Suppose this interface 1 is running, 2 is stop, like it is standby. This buffer don't have any data. Okay.
Okay, so it won't store any data at that time.
It won't store any data.
Okay.
The time it will go down, this will start collecting data and sending to the buffer.
Okay.
And then buffer will send data to the Pi system immediately.
Understood.
So okay, so in this case, in this type of configuration, when one OPC interface is acting and active and running, the other OPC interface is just sitting idle.
Right.
Am I right,
that's what,
Animal?
yeah.
Right. But there are that idleness is also different in different type of failover. Like in cold failover, it is totally idle. In warm failover, it is kind of idle, but it is only receiving tag configuration at certain time, every certain time period. And in another warm, it is creating group. In another warm, it is storing. Means there are different type of warm failover. There is different type of failover. So I will explain it at the time of configuration.
So like any kind of failover, this Pi buffer, is it going to be idle?
No, it is idle. If it is on backup interface, if it is secondary interface, it is idle.
Okay.
Okay. So any other question here?
No.
Okay, fine. So now we are collecting the data. So I have explained you the interface level failover, right? There is second failover called OPC level failover. So in this case, your one interface will be pointing to both the OPCs. Okay. So we will configure it that way. Suppose there is one interface pointing to both the OPCs and OPCs are outside the server. Okay. So suppose let me open my, so this is point 1. And this is point 2. Okay. So in second case, these two OPCs are outside these servers. Okay. So what I am doing, I am configuring this OPC, like this interface, to communicate with Both the OPCs. Same here. And in this case, what will primary interface will do? Primary interface will communicate with primary OPC server. If the primary OPC server is down, it will start communicating to the secondary OPC server. Okay. So this is OPC level failover. And if we do both the level failover, means OPC plus interface, it will look like this. So if interface 1 is working, if OPC 1 is down, it will communicate to 2. If interface 1 is down, this will be your primary interface. Then it will start collecting data from primary OPC. If primary OPC goes down, it will start collecting data from the secondary OPC. Any question here?
If in this case your interface are on, both the interfaces are on the same machine or on the different machine?
No, these are the redundant interface, right? So it should not be in the same machine. Otherwise, there is no use.
Yes. Okay.
So here in this case, we have 4 machines.
Yeah, 4 machines. So
two of the
redundant-
machine is OPC is running, and 2 of the machines.
Right.
5 interface is running. Okay.
Right.
So how will you decide on each of this OPC servers are different, so primary and secondary, so there is nothing on the OPC level, there is no primary or secondary, both will be running independently as it is like they are running. But on the Pi interface, I'll have to mention that which one is your primary and on the which one is your secondary on the Pi interface.
On Pi interface itself, you mention it.
Okay, and you have to mention in both ways, like for Pi interface, the OPC server, one is your primary, one is your secondary, as well as if that is your UFO or not, like both you have to mention, right?
Sorry, come again.
So on your Pi interface, for the OPC server, you have to mention that OPC 1 is your primary or OPC 2 is your primary. That is one configuration you have to do, as well as if Pi interface 1 and 2 are redundant to each other, like primary and secondary is there, then in that case also you have to configure that UFO file in one of those Pi interfaces.
Absolutely right. Exactly.
Okay. You're going to show us all this, right?
Yeah, at the time of interface configuration. Though the OPC
all these, so Animesh, all these type of configuration, you do it in engineering phase or what?
What is mean by engineering phase?
Engineering means how you are going to put the servers, what type of redundancy you will establish. All these things you do all the calculation during the engineering phase of the project or what?
Right. At the very first part, like the planning. What we are looking is total planning, right? So
Okay.
because from the starting, after the architecture I explained, we started the planning thing, right? So right now this everything is planning.
Okay.
So first we planned the project and then we planned the architecture. So right now what we are doing is we are planning the architecture, the implementation planning and HA.
Okay.
So once actually we really don't configure the interface first. We actually configure the server first. Okay. And then we configure the interface. Okay.
So and in the OPC interface, you have all those tools available, right? Like any kind of if any kind of OPC server I'm using, so this file, like what we call it, the service that what's like the integrated tool or what
The
I say, like
interface node.
what?
Instance. Interface instance or software, right?
Yeah, no, interface software. Inside that interface software, there has to be a drop down like what kind of an OPC server I'm looking into.
No. Actually, how it work is, at the time of configuration I will show, but how it work is, the very first thing is you mention the name of the server. Server means the node, right? Either
Yeah.
you put the IP or the host name
Okay.
in one of the like
Column, like on one of the text.
one of
Yeah.
the text box.
Hmm.
Then you click on a button that
The
fetch
drop downs.
all the OPCs. So once you click on that particular server, the IP or the host name you mentioned, it will pull the list of the OPC instance available on that server.
Okay.
And then you can
So
select.
that's internally done by the OP that ICU.
Yeah, ICU. Yeah.
Okay.
Okay.
Yeah.
Right. Then going forward, like what we have seen is the like interface level failure and OPC level failure. Okay. Then going to the Pi server. Okay. So what we have done here is we have considered two separate machines here, one for the Pi server 1 and one for the secondary Pi server. And what we configure, what we call it as a Pi collective. So the terminology we use is Pi collective. So for interface, it is a failover. For servers, it is a collective. Here again, I have kept data archive and AF server on the same system. Okay, but the AF will be two separate instances. So AF will not actually be talking to each other. Okay. But what you will be doing is you will be doing the network load balancer to access the AF. So AF don't have the failover configuration component like we have UFO here and we have Pi collective for the data archive. But for AF, we don't have such component. So for AF redundancy, we need to use network load balancer. Okay. So this is network load balancer. Yeah. Question?
No. Continue.
Okay. For data archive, we have a component called Pi collective. So we will be installing one small component, Pi collective manager, which will be like holding all the config. Like we will be doing all that configuration of redundancy in the Pi collective collection manager. Okay.
So what is the role of this Pi collective? You said.
Yeah. So Pi collection manager is again same type of UFO for Pi server. So it is a small component will reside on like primary server where you will configure like this is the primary server for you and this is the secondary server for you, and all that configuration you will do in Pi collection manager. And like this primary data archive and secondary data archive will be the identical data archive. So both will be holding exact same information, exact same data. Yeah. You get that, or you want more explanation on the Pi collective?
No, can you just little bit explain once again on this I understood this Pi data archive, they both have to be primary and secondary, that's identical, but AF server, they don't have any interconnections between, they don't communicate with each other, right? So
right.
And this Pi collective is a Pi collective manager which manages the AFs, like
which manages the redundancy of data archive. Because
Okay, Pi Collective is managing the redundancy of data archive.
right. Because you need to
And
configure
for
like
AF, we don't have any.
no, for AF we don't have any, so we use a network load balancer.
So can we say in just like in Pi interface, we are using UFO. In
Right.
Pi archive, Pi server, we are using Pi collective.
Right.
And in AF, we use network load balancing.
Exactly.
Okay.
Because like why we are using network load balancing, because we will be using AF frequently. Okay, we will not be using data archive that frequently. Means we will not be communicating directly to data archive that frequently. We will be using AF as a mediator. We most of the time we will be giving call to the AF, and then AF will be pulling data from the data archive for you. Okay, so that is how it works. Because if you do hierarchy in a proper way, then you will be connecting to the AF. If you don't do hierarchy, then you will be connecting to the data archive directly.
And what is this purpose of this Pi AF network load balancer? Like, is it maintaining the redundancy as well, or is it just
So
the load balance?
redundancy is what it does, what it exactly does. Actually, this I will show you in next. Like this, both AF are actually the same instance. It is pointing to the same database. So whatever will be here, the same thing will be here. Okay.
Yeah, but who is maintaining that? Let's suppose I have added a new hierarchy, or I have added a new template. So it's going to get. I have made.
This is how it works. So once you add something, it will go into the PyFD. Okay. Actually, this is cluster. Means this is again redundancy of this.
Okay, so that is inside the same machine, but two different SQL databases.
Actually, these are two separate machines. Actually, sorry for that. Sorry for the confusion. Just give me 1 minute. I will just make it. Okay. Okay. So this is cluster you can consider. Okay. For these two SQL servers. Okay. This is your one SQL server. This is your second SQL server.
Okay.
Okay.
Okay, but how? Let's suppose I have made one configuration change on one of your AF, right?
Right.
So that is going to get reflected on your both the SQL server. That's
right.
No.
Yes. The very first thing is once you do the changes anywhere, it will directly change in PyFD, right?
PyFD, yes.
And you have done the redundancy of PyFD through cluster.
Yes.
So it will automatically reflect on both the.
Yes, but how will the other? Okay, so you're saying that this Pi SRV2 is again looking into the same SQL cluster, so it's going to understand from there itself that okay, so there has been a change.
It will show you the same information because all the information is in same database, right?
Same database. Okay, it's pointing to the same database. So if you change in one, okay. So how this NLB is just basically like maintaining the performance of the system. This AF server.
It is actually for the clients. So whenever one like suppose I am accessing the AF, right? So if I am accessing the AF and one server goes down, then load balancer will automatically
go high.
Move secondary server.
Okay. So load balancer is, what is the role? Load balancer, is it maintaining the performance, or is it switching between AF and
both the ways. So suppose like 100 people are using AF, right?
Okay.
So for some people it will like use the AF1. For some people it will just redirect to the AF2, right? But suppose AF1 is down, then everyone will be redirected to AF2.
Okay, so that redirection, because when I let's suppose I have I'll be using PyVision, so at that time I'll have to select the server. Like when I want to fetch the data, or when I want to fetch a tag, I'll have to go to the AF, and then from that drop down I have to select a tag from there, right?
Right.
So for that, initially first thing is I'll have to select the server, right? So let's
Right.
suppose I'm selecting Pi server 1. So and it is unable to connect. Let's suppose it is unable to connect. Let's suppose Pi server 1 is down at that time, or whatever it is, it's unable to connect. So I'll have to manually move to SRV2, or is it the NLB who will be automatically, even if I select SRV1 and even if it is down, then also it is going to fetch the data through the SRV2 without the user knowing it?
Actually, you will not be pointing to either SRV1 or SRV2. Okay. If you are on PyVision, either you will be pointing to the Pi collective or AF server. In this case, both the AF server will be having the same name. I am not referring to the machine. I am referring to the AF server instance. So let me take a remote so I will explain you in a better way. नेटवर्क वहां का स्लो लग रहा है.
ये किसी प्लांट का है क्या?
हाँ, ये कनाडा का ही है.
अच्छा अच्छा.
तो एक्चुअली ये दिख रहा है आपको EVTV SRV पाई.
हाँ हाँ,
ये एक्चुअली मेरा होस्ट है, मतलब ये एक्चुअली मेरा पाई सर्वर है. ओके. और ये जो है ना EVTV AFDB, ये मेरा डेटाबेस है. लेकिन मेरा जो AF सर्वर है ना, वो ये सर्वर के ऊपर, ये होस्ट के ऊपर नहीं है. मेरा जो AF सर्वर है ना, उसका होस्ट नेम अलग है. आई विल शो यू. वो बहुत ही खराब है यार वहां का. मेरा तो ठीक ही है. ठीक है.
मैं अपना सिस्टम ले लूं, सेम मेरा जो ये है AF सर्वर है
ना, चलेगा. उसका कोई दिक्कत नहीं है. मेरा ये आ गया है. मैं एक्चुअली ये
अच्छा
परफेक्ट एग्जांपल है, क्योंकि मेरा AF और मेरा पाई सर्वर अलग अलग जगह पे.
ओके
बस
ओके.
क्या है, उनका नेटवर्क खराब लग रहा है मुझे। मेरा तो अच्छा दे रहा है 300 MBPS। ठीक है, अभी अगर आप देखोगे इसके ऊपर मेरा AF है, लेकिन ये सर्वर का नाम अलग है और मेरे AF इंस्टेंस का नाम अलग है। AF इंस्टेंस का नाम मैं डिफाइन कर सकता हूं कि क्या है। बहुत ही गंदा
यहाँ पे AF सर्वर का नाम क्या है?
इफ यू आर रेफरिंग टू द हार्डवेयर, तो यहाँ पे AF सर्वर का नाम है AVTB पाई AF। ओके, लेकिन मेरे AF सर्वर इंस्टेंस का नाम जो है वो AVTB SRV पाई ही है, ऐसा है वो। सपोज मैं आपको,
ये इसमें क्लैरिटी नहीं है, समझ में नहीं आया ये मतलब।
तो वही मैं बता रहा हूँ आपको, रुको अभी। ठीक है, ये भूल जाओ। अभी मेरे 2 सर्वर हैं, ये ठीक है, ये मेरे पाई सर्वर है 2। और अभी एक अलग कंडीशन लेते हैं, ये मेरा AF है, AF है। ओके, कि मैं जब कलेक्टिव करता हूं, ठीक है, जब मैं पाई कलेक्टिव करता हूं तो ये सब मेरा एक इसमें आ जाएगा। ठीक है, ये मेरा एक पाई कलेक्टिव है सर्वर का, मतलब डेटा आर्काइव का। ओके, तो यहाँ पे मैं कॉन्फ़िगर करूंगा कलेक्टिव, यहाँ पे मैं डिफाइन करूंगा 1 क्या है 2 क्या है, लेकिन मेरे पाई सर्वर का नाम क्या रहेगा, पाई SRV, सपोज TSMC का है, राइट, TSMC पाई SRV, ये मेरा सर्वर का इंस्टेंस है, ये मेरे कलेक्टिव का नाम है। ठीक है, भले ही मेरे सर्वर का होस्ट नेम ये है और ये है, फर्क नहीं पड़ता है, लेकिन मेरे पाई सर्वर का इंस्टेंस जो है ना वो ये नाम है। सेम वे में ये मेरे 2 जो है ना, ये मेरे 2 AFs के सर्वर है, सपोज 2 अलग अलग सर्वर है मेरे, लेकिन मेरा जो AF सर्वर का इंस्टेंस जो है ना उसका नाम सेम रहेगा, ये SMC पाई AF। ठीक है, सपोज
तो हम सर्वर का इंस्टेंस को एक्सेस कर रहे हैं क्या, मतलब?
राइट, तो आप जब भी कनेक्ट करते हो ना, जब भी कॉन्फ़िगर करते हो ना, जैसे मैं अगर यहाँ पे दिखाऊं, ठीक है, अगर मैं यहाँ पे दिखाऊं तो मैंने यहाँ पे क्या किया है, देखो यहाँ पे मैंने AVTB SRV पाई करके जो मेरा सर्वर है इंस्टेंस पाई का, ये पाई का पाई डेटा आर्काइव का इंस्टेंस है। ठीक है, मेरा AF सर्वर भले ही दूसरे सर्वर पे है, लेकिन मैंने उसका भी नाम सेम दे रखा है, ये मेरा AF है।
ओके,
मतलब इसका होस्ट नेम, मतलब इसके कंडीशन में अगर मैं, जो क्लाइंट है मेरा उसके कंडीशन में बताऊं तो मेरा उनका एक ही है ये।
तो AF सर्वर जब बोलते हो मतलब उसका SQL उसमें है ना?
हाँ, तो मेरा क्या है बताया क्या, ये इसका होस्ट नेम सेम है, AVTB SRV पाई, इसका होस्ट नेम और मेरा पाई सर्वर का नाम सेम है। ठीक है, इस कंडीशन में, लेकिन मेरा जो AF होस्ट किया है मैंने,
मतलब इसमें जो है आपका SQL सर्वर है, यही ना?
हाँ, तो इसमें
मतलब AF सर्वर में हमारा SQL सर्वर है।
तो ये देखो, ये होस्ट नेम हो गए, ये दो होस्ट नेम हो गए सर्वर के, ये दो सर्वर
ठीक
है।
है।
लेकिन मैंने मेरे डेटा आर्काइव का नाम और मेरे AF का नाम सेम रखा है। तो मैं क्या करता हूं, मैं सर्वर को कनेक्ट नहीं करता हूं, ये जो होस्ट नेम है, मैं होस्ट नेम को कनेक्ट नहीं करता हूं। मैं जो कनेक्ट
ओके,
करता हूं वो AF
सर्वर
के
को।
इंस्टेंस को कनेक्ट करता हूं।
अच्छा, तो ये बोल सकते हैं कि ये पीसी नेम है।
हाँ,
ये पीसी नेम है ना, ऊपर वाले जो है वो पीसी नेम है।
नहीं नहीं, ये अंदर वाला पीसी नेम है।
अच्छा, अंदर वाला पीसी नेम है,
हाँ,
और
ये
ऊपर वाला
पीसी,
फिर
तो
क्या है?
इस केस में
ये AF का मैंने
इंस्टेंस
सर्वर
नेम है।
इंस्टेंस का नाम दिया है मैंने, AF का इंस्टेंस का।
तो अभी इस जो इंस्टेंस नेम है AVTV SRV P1 के नाम के अंदर मेरे पास एक सर्वर है, एक AF सर्वर है, एक पाई सर्वर भी है।
नहीं, इसमें सिर्फ AF सर्वर है, इसमें पाई सर्वर नहीं है।
नहीं, दोनों का इंस्टेंस तो सेम है ना, ABTV SRV P1 पाई, ABTV SRV पाई।
हाँ, लेकिन ये AF सर्वर का नाम दिया है मैंने, और ये डेटा आर्काइव का नाम दिया है मैंने, सेम रखा है डेटा आर्काइव और AF सर्वर का नाम, मतलब इंस्टेंस का नाम।
तो ये जो मैं पूछ रहा था, ये जो AF सर्वर है, इसमें ही आपका SQL सर्वर भी AF सर्वर में ही रखे हो आप?
राइट राइट।
तो SQL सर्वर फिर और अलग से फिर आपको सेटअप करने की जरूरत नहीं है, जो आप AF सर्वर बोल रहे हो उसमें आपका SQL सर्वर भी है।
इस केस में लेकिन
अच्छा,
आपको अगर क्या रहता है, आपका रिक्वायरमेंट कैसा है ना, उसके ऊपर। अभी अगर मेरा SQL सर्वर एक ही इसमें रखा और वो उड़ गया तो क्या करूंगा मैं? तो
हाँ,
अलग अलग लोगों का रिक्वायरमेंट अलग अलग है। कुछ कुछ लोग तो रिडंडेंसी किसी भी चीज की नहीं लेते हैं। अभी AVDB में ना मेरी इंटरफेस रिडंडेंसी है, ना सर्वर पाई सर्वर डेटा आर्काइव रिडंडेंसी है, ना AF रिडंडेंसी है। तो ये आपके ऊपर है कि आप रिडंडेंसी कौन सी लेवल पे लेते हो। कुछ लोग सिर्फ इंटरफेस रिडंडेंसी लेते हैं, पाई सर्वर रिडंडेंसी नहीं लेते। कुछ लोग इंटरफेस और पाई सर्वर रिडंडेंसी लेते हैं, लेकिन SQL का क्लस्टर नहीं करते। वो बोलते भाई मेरे पास इतना पैसा नहीं है कि मैं दो दो SQL सर्वर डालूं, क्योंकि अगर एंटरप्राइज डालना है तो उसकी कॉस्टिंग ज्यादा जाती है, हार्डवेयर ज्यादा जाता है, ऊपर से SQL क्लस्टरिंग करना पड़ता है, उसके पैसे अलग से लगते हैं। तो वो बोलते हैं कि भाई मैं डेटाबेस तो एक ही रखूंगा।
नहीं तो एक बात बताइए कि ये जो आप डॉटेड लाइन जो AF वाला है, वो आप SRV1 और SRV2 से AF को हटा के वो जो डॉटेड वाला AF है उसको आप वहां पे AF सर्वर को अलग कर दिए,
राइट राइट, मतलब
राइट?
आप एक में भी रख सकते हो या फिर आप सेपरेट भी कर सकते हो।
सेपरेट भी कर सकते हैं। तो अभी जो आप AF बोले हो, AF मतलब सिस्टम एक्सप्लोरर आपके हिसाब से, मैं यही समझ रहा हूँ,
AF,
जिसमें आप
यस, एसेट फ्रेमवर्क का इंस्टेंस मतलब AF, मतलब जो जिसके लिए आपको UI सिस्टम एक्सप्लोरर से मिलता है।
हाँ, जिसके लिए यूआई मेरे को सिस्टम एक्सप्लोरर से मिलता है। तो इज इट पॉसिबल कि मेरा जैसे इस केस में है आपका एसक्यूएल सर्वर अलग है, एएफ का इंस्टेंस आप अलग बैठा के रखे हो। हम मेरे यहाँ पे टीएसएमसी का स्ट्रक्चर के हिसाब से मैं इसको समझने की कोशिश कर रहा हूँ। मेरे केस में क्या हो रहा है कि मेरा यहाँ पे 2 है, एक है मेरा पाई सर्वर है, एक है मेरा एसक्यूएल सर्वर और एल्स एएफ सर्वर हम बोल रहे हैं। ठीक है? तो मेरा जो एएफ सर्वर है, जब मैं चेक कर रहा हूँ तो मेरे को दिख रहा है कि जो मेरा जो डाटा आर्काइव है वो तो मेरा पाई सर्वर में ही है, वो तो छोड़ देते हैं। लेकिन जब मेरा एसक्यूएल सर्वर या फिर पाई एएफ सर्वर आता है, एएफ उसमें ये दोनों कंबाइंड है मेरा। एसक्यूएल सर्वर और एएफ सर्वर कंबाइंड है। लेकिन हेलो?
हाँ, बोलो ना, बोलो।
लेकिन इसमें हो रहा है कि जब भी मैं एक्सेस करता हूँ डेटा को, मतलब मुझे एएफ को कॉन्फ़िगर करना है, जैसे मेरा सिस्टम एक्सप्लोरर जो है, यूआई जो है, वो मेरा पाई सर्वर के थ्रू ही है। तो इज़ इट पॉसिबल और मेरी अंडरस्टैंडिंग में कुछ प्रॉब्लम गलती है?
नहीं, UI तो आप जहाँ पे AF इंस्टॉल्ड है ना आपका, वहां पे भी ओपन हो सकता है, क्योंकि वहां पे भी सिस्टम एक्सप्लोरर तो इंस्टॉल हुआ ही होगा।
हाँ, वहाँ पे भी कर सकते हैं, बट मैं पाई पाई सर्वर से भी मैं कर सकता हूँ। तो लेकिन मुझे उस खाली सेलेक्ट करना पड़ता है कि मेरा एएफ सर्वर कौन-सा है।
राइट राइट, क्योंकि क्या हुआ होगा, आपने जब AF सर्वर इंस्टॉल किया ना, तब आपने उधर के होस्ट का नाम दिया होगा उसको, राइट? तो वही आपके ऊपर है, आप होस्ट नेम कुछ भी दे सकते हो, मतलब आपका सर्वर नेम कुछ भी हो फर्क नहीं पड़ता है। मुझे अगर मेरा नाम देना है AF के इंस्टेंस को, तो मैं मेरा नाम भी दे सकता हूँ।
ओके, तो AF का तो इंस्टेंस पता नहीं, बस मुझे दिख रहा है कि पीसी नेम है, तो पीसी नेम जो मेरा एसक्यूएल सर्वर जैसे 2003 SQL 02 है, तो उसी में मेरा AF सर्वर भी है, तो वो मैं आपको दिखाने से आप पता कर पाओगे कि किसमें क्या है वो। अभी तो
है क्या
इंस्टेंस
आपके पास रिमोट है क्या अभी?
हाँ हाँ, अभी है मेरे पास रिमोट, मैं आपको दिखाता हूँ, एक सेकंड। आप स्क्रीन शेयरिंग बंद करो, मैं रिमोट लेता हूँ इसको।
एक मिनट।
दिख रहा है ना मेरा स्क्रीन?
हाँ हाँ,
ये तो आपका वाला मशीन हो गया, तो डेस्कटॉप लेता हूँ। इसमें पाई का कुछ रखा है, पाई का नहीं है, ठीक है। हाँ, तो इसमें जैसे है, तो ये मेरा हो गया जो मेरा SQL, ये जैसे ऊपर में जैसे मेंशन है यहाँ पे देखिए 2003 SQL 02, ये बट मेरा पाई सर्वर है। दिस इज ये जिस सिस्टम को मैं खोला हूँ, दिस इज 2003 HIST 02, बट वो रेफरेंस जो ले रहा है वो 2003 SQL 02 को ले रहा है यहाँ पे।
एक मिनट।
ये देखिए, ये जो ले रहा है SQL 02 को ले रहा है कॉन्फ़िगरेशन में, but my system name is something different. My system name is डेस्कटॉप कहाँ गया? देखिए, ये 2003 हिस्टोरियन 02 है ये,
राइट।
ठीक है। मतलब ये मेरा, इसमें मेरा पाई डेटा आर्काइव है। दिस मशीन इज हैविंग पाई डेटा आर्काइव, बट व्हेन यू ओपन दिस सिस्टम एक्सप्लोरर फ्रॉम हियर, इट इज पॉइंटिंग टू 2003 SQL 02 DSOT, which is my जो ये है मेरा फाइल का डेटाबेस का जो रेफरेंस है, इसके अंदर में ये
राइट, क्योंकि क्या है कि आपने जब वहां पे बनाया है सर्वर, मतलब AF जब इंस्टॉल किया है, तो उसने इंस्टॉलेशन के टाइम पे एक्सप्लिसिटली मेंशन नहीं किया। हम ऐसे नहीं करते, हम होस्ट नेम ऐसे रख के उसके हिसाब से AF सर्वर को नाम नहीं देते, क्योंकि क्या होता है इससे जो यूजर है ना, उनको कनेक्ट करने में दिक्कत होती है। क्योंकि अभी क्या है, आपके केस में गिने चुने यूजर थे, 3-4 लोग जो कुछ है, राइट। बट जब यूजर बढ़ेंगे, जब 20, 25, 50 यूजर हो जाएंगे, तो उनको है ना दिक्कत जाता है ये सर्वर का नाम याद रखने में। तो हम है ना प्रॉपरली नेमिंग करते हैं, जैसे मैंने यहाँ पे किया है ना, ABTV SRV पाई करके वगैरह।
ये कहाँ करते हैं? आप जो इंस्टेंस बोल रहे हैं, ये इंस्टेंस इज माय DSOT, राइट?
हाँ, तो आपका क्या है, ये नहीं, ये DSOT इज योर डेटाबेस एक्चुअली। मैं आपको बताऊंगा जब अपन इंस्टॉल करेंगे ना।
ओके ओके।
तो ये एक चीज बताऊंगा मैं आपको कि आप पाई सर्वर का नाम कहाँ पे मेंशन करते हो, आप AF सर्वर का नाम कहाँ पे मेंशन करते हो, और आप डेटाबेस कहाँ पे क्रिएट करते हो। तो आप मल्टीपल डेटाबेसेस भी क्रिएट कर सकते हो।
ओके ओके
ओके। तो अभी ये जो है, ये जो मैं रिडंडेंसी दिखा रहा था, तो ये फुल एंड टू एंड रिडंडेंसी है। मतलब इंटरफेस से लेके पाई डेटा आर्काइव से लेके AF से लेके आपका SQL सर्वर भी, मतलब हर जगह पे हमने रिडंडेंसी ली है। हर जगह पे रिडंडेंसी हमने अलग तरीके से कॉन्फ़िगर किया है। इंटरफेस में यूनियन फेलोवर से किया है।
आप स्क्रीन शेयर कर लीजिए, अभी मेरा स्क्रीन
किया है मैंने ऑलरेडी।
नहीं दिख रहा है।
दिख नहीं रहा है।
अभी
हाँ अभी दिख रहा है।
ओके। तो अगेन मतलब हमने क्या किया, इंटरफेस लेवल पे यूनियन फेलोवर यूज किया है, डेटा आर्काइव लेवल पे पाई कलेक्टिव यूज किया है, AF लेवल पे हमने क्या किया है, एक्चुअल रिडंडेंसी, मतलब हमने सिर्फ 2 बार इंस्टॉल किया है उसको, लेकिन हम पॉइंट आउट एक ही डेटाबेस के कर रहे हैं, और लोड बैलेंसर यूज कर रहे हैं ताकि अगर यूजर यूज कर रहे हैं तो यूजर को ऑटोमेटिकली रिडायरेक्ट किया जाए, कि अगर ये सर्वर अवेलेबल नहीं है तो लोड बैलेंसर ऑटोमेटिकली यूजर को सेकेंडरी सर्वर पे रिडायरेक्ट करेगा। ठीक है, लेकिन डेटाबेस एक ही यूज हो रहा है। फिर डेटाबेस लेवल रिडंडेंसी की है हमने SQL सर्वर क्लस्टरिंग यूज करके। ओके। अभी मैंने ये AF बाहर क्यों निकाला है, क्या है, अगेन AF बाहर 2 कारणों से निकालते हैं हम। मतलब कारण तो एक ही रहता है मेन, कि अगर आपके रिसोर्सेस शेयर हो रहे हैं और सिस्टम मतलब परफॉर्मेंस लो हो जाएगा। ये 2 कंडीशन में होता है, एक तो आपका सिस्टम बड़ा है, मतलब सर्वर का टैग ज़्यादा है, कैलकुलेशन ज़्यादा है, तो हम सेपरेट करते हैं पाई सर्वर से। या फिर अगर आप क्या करते हो कि RTQP इंजन यूज करते हो क्वेरी करने के लिए डेटा, क्या होता है बहुत बार बाहर डेटा पुल करना रहता है, तो RTQP इंजन अगर यूज करते हैं तो आपको क्या करना पड़ता है, RTQP इंजन भी सेम सर्वर पे इंस्टॉल करना पड़ता है। तो मतलब जहां पे AF है, तो उस कंडीशन में क्या होता है, ये और स्लो हो जाता है। तो उस कंडीशन में हम क्या करते हैं, AF बाजू में ले लेते हैं और यहीं पे RTQP इंजन इंस्टॉल करते हैं। ठीक है,
क्या इंजन बोला?
RTQP।
वो क्या होता है RTQP?
वो एक्चुअली क्या है कि एक्सटर्नल जो सिस्टम्स रहता है, कभी कभी वो यूज करते हैं AF से डेटा पुल करने के लिए।
ओके ओके।
वो क्या आपके कंडीशन में नहीं रहेगा, लेकिन अगर कोई अलग अलग सिस्टम्स है जिसको AF से डेटा चाहिए तो वो कभी कभी यूज करते हैं। वो इट इज वेरी रेयर बट करते हैं लोग। तो ये हो गया आपका AF लेवल का और डेटाबेस लेवल का फेलोवर। फिर आता है आपका पाई विजन। ठीक
तो
है,
इसमें एक क्वेश्चन है, जैसे UFO हम इंस्टॉल करते हैं, UFO एक एप्लीकेशन है जिसको हम इंस्टॉल करते हुए कोई एक पाई इंटरफेस में।
नहीं, UFO के कंडीशन में वो एप्लीकेशन नहीं है, इट इज ओनली अ फाइल विच इज ऑटोमेटिकली जनरेटेड बाय पाई ICU। ओके, मतलब ये इंटरफेस से ऑटोमेटिकली जनरेट होती है।
ठीक है, तो और पाई कलेक्टिव भी ऑटोमेटिकली जनरेट होता है?
कलेक्टिव का एक कंपोनेंट है, वो एक सेटअप है, वो इंस्टॉल करना पड़ता है।
वो कोई भी एक पाई सर्वर में इंस्टॉल कर सकता है।
राइट, मोस्टली हम प्राइमरी में करते हैं, लेकिन आप कोई भी एक
Primary.
सर्वर में इंस्टॉल कर सकते हैं।
ओके, सो सेपरेट सिमिलरली एनएलबी जो है वो क्या है, वो एप्लीकेशन है
नेटवर्क
या
लोड बैलेंसर है। ये मोस्टली क्या रहता है, नेटवर्क लोड बैलेंसर आपका एक सेपरेट सर्वर रहता है। वो क्या करता है, वो बैलेंस करता है दोनों सिस्टम्स के बीच में, मतलब
ओके, वो एक सेपरेट सर्वर रहेगा।
हाँ, वो एक सेपरेट सर्वर, एक आपका सिस्टम रहता है नेटवर्क लोड बैलेंसर का। वो क्या करता है, दोनों में से मतलब ट्रैफिक डिस्ट्रीब्यूट करते रहता है, या फिर कोई एक सिस्टम डाउन हो जाए तो ट्रैफिक रिडायरेक्ट करता है।
ओके,
ठीक है, ये एक्चुअली ये विंडोज का कंपोनेंट है। मतलब आप सर्वर, ये नेटवर्क लोड बैलेंसर आप नॉर्मली भी करते हो। अगर कोई वेबसाइट है, राइट, या आपका शेयर पॉइंट सर्वर भी हो गया, या कोई सॉरी शेयर पॉइंट सर्वर हो गया, आपका एसएपी सर्वर, मतलब ये ऑटोमेटिकली नेटवर्क लोड बैलेंसर आपके वेबसाइट को मैनेज करने का भी काम करता है। तो ये तो नॉर्मल कंपोनेंट है, इसका पर्टिकुलरली पाई से लेना देना नहीं है कुछ, ये इन जनरल है। सिमिलरली एसक्यूएल क्लस्टर, फर्क नहीं पड़ता पाई का डेटाबेस है या कोई है। अगर आपको डेटाबेस रिडंडेंसी करनी है एसक्यूएल की, तो आप क्लस्टरिंग यूज करते हो।
ओके,
सो ये कोई भी कंपनी का हम ले सकते हैं क्या, एनएलबी?
हाँ, नेटवर्क लोड बैलेंसर तो कहीं पे भी आपको, मतलब जो कोई इम्प्लीमेंट करके देगा।
अच्छा अच्छा, मतलब ये आप लोग सेटअप नहीं,
नहीं, ये
इंस्टॉलेशन?
सेटअप नहीं है, पाई का कोई सेटअप नहीं है, पाई से कोई लेना देना नहीं है इसका।
ओके ओके। तो ये हम रख भी सकते हैं, इवन नहीं भी रख सकते, इट्स अप
हाँ,
टू।
मतलब आपके ऊपर है, आपको अगर एएफ के रिडंडेंसी करना है तो रखो, नहीं तो नहीं रखो।
लेट सपोज हम 2 एएफ रखे हैं बट हम एनएलबी नहीं रखे हैं, तो ये क्या मेरा पर्पस फुलफिल नहीं करेगा?
नहीं, क्या होगा पता है क्या, आप क्या करोगे, 2 एएफ रखोगे, बराबर है, लेकिन क्योंकि नेटवर्क लोड बैलेंसर नहीं है, तो आप जब कॉल करोगे ना,
हाँ।
तो वो किसी एक ही से सिस्टम पे चला जाएगा, और फिर आपको मैन्युअली भी, अगर वो एक बंद होता है तो ऑटोमेटिकली दूसरे पे स्विच नहीं होगा।
हम्म।
बाकी कुछ नहीं, वो दोनों सेपरेटली चलते रहेंगे ऐसे।
मतलब एफ 2 रख रहे हैं तो एनएलबी रखना ही पड़ेगा, अदरवाइज देयर इज नो यूज ऑफ 2 एफ।
हाँ, राइट राइट। तो वो क्या है, आपका वो कोल्ड स्टैंड बाय टाइप हो जाएगा वो। फिर पाईविजन का भी सेम है। पाईविजन का भी क्या है, आपका वेब कंपोनेंट है, तो पाईविजन का भी क्या करेगा, पाईविजन ये रिडंडेंस, पाईविजन जो डेटाबेस है उसको पॉइंट आउट करता रहेगा। और यहाँ पे भी एक्चुअली आपको लोड बैलेंसर लगेगा, यहाँ पे मैंने मेंशन नहीं किया है, तो यहाँ पे भी आप लोड बैलेंसर ही यूज करोगे, क्योंकि वो क्या करेगा, आपका ट्रैफिक दोनों में से, 2 सर्वर में से एक सर्वर पे रिडायरेक्ट करेगा, क्योंकि ये वेब एप्लीकेशन है, राइट। तो ये दोनों में से एक सर्वर पे रिडायरेक्ट करेगा। अगर एक सर्वर डाउन हो गया तो सारा का सारा ट्रैफिक सेकंड सर्वर पे लेके जाएगा।
ठीक है। अब दोनों को बैलेंस भी कर सकता है, मतलब डिपेंडिंग अपॉन कि उसको मेरे को 50-50 लोड पे मेंटेन करना है, तो उस केस में भी वो हेल्प करेगा एप्लीकेशन लेवल
लोड
पे।
बैलेंसर का एक्चुअली काम वही रहता है, मेजर काम वही रहता है उसका, मतलब इट मेक श्योर कि
एक
लोड
सिस्टम पे लोड ज्यादा ना हो जाए, परफॉर्मेंस मेंटेन
डिस्ट्रीब्यूट
करता
होते
है।
रहे लोड, और मतलब वो उस हिसाब से रिडायरेक्ट करता है। अगर एक डाउन हो जाता है तो फिर उसको बाय डिफॉल्ट एक पे रिडायरेक्ट करना ही पड़ता है सबको, फिर उसका
तो
परफॉर्मेंस।
वो एप्लीकेशन लेवल पे वो लोड बैलेंसिंग हेल्प करता है?
हाँ, वेब एप्लीकेशन लेवल पे ही तो मेनली यूज होता है लोड बैलेंसर।
अच्छा।
ठीक है, तो ये
ठीक
हो
है।
गया आपका हाई अवेलेबिलिटी, ऑलमोस्ट ऑल द कंपोनेंट्स। यहाँ पे कोई क्वेश्चन?
नहीं।
तब तो क्लियर है।
उसके बाद अपना है पाई इंटरफेस एंड पाई कनेक्टर्स। मतलब यहाँ पे आप देख सकते हो कि पाई इंटरफेस कैसे, क्या डिफरेंस है मेनली। तो ये क्या है कि जो एक्सटर्नल डेटा सोर्सेस है उससे डेटा कलेक्ट करता है डिफरेंट डिफरेंट प्रोटोकॉल्स पे। मतलब कोई ओपीसी पे काम करता है, कोई जो बोलते हैं हम सीरियल पोर्ट के लिए मॉड बस या प्रॉफी बस जो यूज होता है वो। ओके, और मतलब इसका पाई इंटरफेस का ऐसा है कि आपको हर चीज खुद से कॉन्फ़िगर करनी पड़ती है. इट्स डोंट टेक एनीथिंग ऑटोमेटिकली. तो आपको पाई टैग कॉन्फ़िगर करने तो आपको मैन्युअली कॉन्फ़िगर करने सारे पाई टैग. आपको अगर AF कॉन्फ़िगर करना है तो आपको मैन्युअली AF कॉन्फ़िगर करना है वगैरह. इंटरफेस में ऐसे रहता है. कनेक्टर्स का ऐसा रहता है कि वो इंटरफेस जैसे ही काम करता है, लेकिन स्पेसिफिक हो सकता है वो कि एक स्पेसिफिक टाइप के डेटा सोर्स के लिए, जैसे पाई कलेक्टर फॉर डेल्टा वी DCS है, या पाई कलेक्टर फॉर एनी अदर DCS, और पाई कलेक्टर फॉर UA OPC UA है. तो ऐसे रहता है. लेकिन ये पाई कलेक्टर का बेनिफिट्स ये रहते हैं कि इट डूज मेनी थिंग्स ऑटोमेटिकली फॉर यू. जैसे अगर आप डिफाइन कर देते हो या कॉन्फ़िगर करके रखते हो, तो जैसे ही आपका टैग क्रिएट होता है डेटा सोर्स साइड में, और आपने डिफाइन कर रखा है कि इस तरीके का अगर टैग क्रिएट होता है तो वो ऑटोमेटिकली पाई सर्वर में बना दे, तो वो ऑटोमेटिकली वो कॉन्फ़िगरेशन लेके पाई सर्वर में टैग बना देगा आपका, और आपका डेटा ऑटोमेटिकली आना शुरू हो जाएगा. तो आपको अगर डेटा सोर्स साइड टैग बनता है तो ऑटोमेटिकली इधर बना देगा. सिमिलरली वो AF भी ऑटोमेटिकली आपका कॉन्फ़िगर कर सकता है. जैसे कि बहुत सारे DCS आप जब इंप्लीमेंट करते हो तो DCS में हायरार्की ऑटोमेटिकली, मतलब नॉट ऑटोमेटिकली, DCS में आपकी हायरार्की बनाते हैं जब इंप्लीमेंट करते हो तो, बराबर. तो उस वहां से वो ऑटोमेटिकली आपकी हायरार्की उठा के AF में हायरार्की बना सकता है. तो
मतलब हमारा OPC सर्वर का रिक्वायरमेंट को वो हटा देता है, डायरेक्टली हम जो डिवाइस है उससे हम बात कर सकते हैं.
नहीं OPC
और
सर्वर,
वॉइस क्लियर नहीं हुआ.
सॉरी.
हेलो.
हाँ हेलो.
हाँ, मैं बोल रहा था कि जैसे OPC कनेक्टर है, तो हम लोग OPC इंटरफेस में क्या करते हैं कि हम लोग जैसे OFS सर्वर्स को एक मतलब एक एज अ मीडिएटर हम लोग इन बिटवीन यूज करते हैं कोई भी डिवाइस से कम्युनिकेट करने के लिए, कोई डिवाइस से डेटा फेच करने के लिए. इन केस ऑफ इंटरफेसेस, दैट OFS सर्वर इज माय इंटरफेस, बट इन केस ऑफ एन OPI connector, so any device, field devices can, like it can be a controller, it can be any smart device, but it can send data directly to the PI server. Am I
नहीं
right?
नहीं, in collector it is not the case. In collector it is again connect to the OPC kind of thing only. Okay, either it is connecting to your DCS, okay, but it is sending data through OPC only. But only plus point is it pulls the hierarchy from your DCS, it pulls the tag configuration from your DCS and OPC and create it automatically into the PI server. In the case of adapters, there are different type of adapters which collect data from different type of devices like IoT devices, sensors, or cloud devices. Like
एक सेकंड जस्ट एक मैं पहले दो को में हम क्लियरिटी थोड़ा सा कर लेते हैं. ये पाई इंटरफेसेस जो है, ये पाई इंटरफेसेस में हम लोग को क्या करना पड़ता है कि वंस हम लोग पाई इंटरफेस मतलब OPC के साथ कनेक्शन हम लोग एस्टैब्लिश कर लिए, देन वी हैव टू क्रिएट, मतलब इम्प्लिसिटली एक्सप्लिसिटली वी हैव टू क्रिएट एवरी पाई पॉइंट्स, राइट?
राइट, एवरी पाई पॉइंट्स आपको एक्सप्लिसिटली क्रिएट करना पड़ता है. दो यू क्रिएट इट इन बल्क यूजिंग एक्सेल एंड ऑल, बट आपको हर बार वो क्रिएट करना ही पड़ता है.
करना पड़ेगा, हाँ
ऑटोमेटिकली.
हाँ, बट पाई कनेक्टर में हमको वो एक्सप्लिसिट जो ऑपरेशन है वो और मेरे को मुझे करना नहीं पड़ेगा, वो डायरेक्टली मेरा पाई पॉइंट्स में अवेलेबल हो जाएगा. आप यही बोलना चाह रहे हैं?
कॉन्फ़िगर इट दैट वे कि पाई कनेक्टर आपका स्पेसिफिक टाइप के जो पॉइंट्स है वो ऑटोमेटिकली क्रिएट करे आपके लिए पाई में.
So
इधर वी आर यूजिंग इंटरफेस. बोलो.
So एक अगर PLC से मैं मेरा पाई कम्युनिकेट कर रहा है, I have two options. I can use Pi interface and I can use Pi connector. कोई भी यूज कर सकता हूँ क्या? ऐसा है क्या?
जरूरत नहीं कि आपके PLC के लिए पाई कनेक्टर अवेलेबल हो. So Pi connector is available for certain type of specific systems only. So Pi connectors are not allowed for every type of data source. It is specifically designed for certain type of data sources.
तो उस केस में पाई इंटरफेस भी काम करता है?
हाँ, ये देखो पाई इंटरफेस क्या है, जेनेरिक है. सपोज आप कोई भी DCS पकड़ो, उसके बाद आपका OPC आता है, तो आप इंटरफेस से कनेक्ट कर सकते हो. ओके, तो इंटरफेस इज कनेक्टिंग टू एनी OPC or any RDBMS database or any UFS. Okay, but the connector इस आप देखोगे यहाँ पे लिखा होगा कहीं पे, दे आर डिजाइन टू रिक्वायर मिनिमल कॉन्फ़िगरेशन ऑफ सिंपली द कलेक्टिंग द स्पेसिफिक डिवाइस प्रोटोकॉल।
Specific device protocol.
ठीक है, तो ये क्या है कि इनिशियली क्या हुआ, जो बड़े बड़े OEMs है, जैसे वंडरवेयर जो है अभी अविवा का ही है, लेकिन जैसे डेल्टा भी था, राइट, डेल्टा भी है, या फिर अदर कोई DCS, बड़े बड़े DCS है, सीमेंस का DCS हो गया, बराबर है। तो
बराबर।
इनके लिए स्पेसिफिकली OSI ने कनेक्टर डेवलप किए थे स्पेसिफिकली इनके लिए। तो इस तरीके के बहुत सारे सिस्टम्स हैं जिसके लिए OSI ने स्पेसिफिकली कनेक्टर्स डेवलप किए हैं। तो वो वहां से ऑटोमेटिकली डेटा उठा के आपके लिए टैग्स और AF बना देता है, अगर आप उस तरीके से कॉन्फ़िगर करते हो तो, अगर आप चाहते हो तो। और एडेप्टर क्या है, एडेप्टर इज अ न्यू थिंग। तो अभी क्या हो रहा है कि बहुत सारे नए नए प्रोटोकॉल्स आ रहे हैं, जैसे MQTT हो गया जो क्लाउड के लिए मोस्टली यूज होता है वगैरह, तो या फिर छोटे छोटे एज डिवाइसेस हो गए। एज डिवाइस मतलब क्या आप हर जगह पे विंडोज ऑपरेटिंग सिस्टम नहीं इंस्टॉल कर सकते हो। ऊपर के दोनों के लिए आपको विंडोज ऑपरेटिंग सिस्टम लगती है, लेकिन क्या होता है बहुत बार विंडोज ऑपरेटिंग सिस्टम नहीं रहती है। छोटे छोटे जो माइक्रो कंट्रोलर्स रहते हैं या फिर छोटे जो डिवाइसेस रहते हैं वहाँ पे कंप्यूटिंग रहती है, लेकिन वो दूसरी ऑपरेटिंग जैसे लिनक्स वगैरह इंस्टॉल रहती है। तो ऐसी जगह पे आप एडेप्टर्स इंस्टॉल कर सकते हो और डेटा पुल कर सकते हो वहाँ से। एनी क्वेश्चन?
एक बार और एडेप्टर
ये
का बता
adapter-
दीजिए था।
ये देखो एडेप्टर कैसे है, न्यू कंपोनेंट। आजकल IoT बहुत हो गया है, बराबर है, तो हर कोई अपने हिसाब से डिवाइसेस डेवलप कर रहा है डेटा कलेक्शन के लिए। तो बहुत बार क्या होता है कि हर जगह पे आप पूरा सर्वर नहीं लगा सकते हो जिसमें आप विंडोज ऑपरेटिंग सिस्टम या पूरा सिस्टम नहीं लगा सकते हो, राइट। तो कुछ कुछ जगह पे जैसे स्लिप कंप्यूटर्स रहते हैं जिसमें प्रोप्राइटरी ऑपरेटिंग सिस्टम रहती है, जैसे लिनक्स डालते हैं, कोई ओपन सोर्स ऑपरेटिंग सिस्टम रहती है, बराबर है, या फिर तो ऐसी जगह पे है ना आपके एडेप्टर इंस्टॉल हो सकते हैं। ओके, जो आपके आप जो IoT के लिए प्रोटोकॉल्स है जैसे MQTT हो गया, या फिर जो एज डिवाइसेस है, एज डिवाइसेस तो पता हो गया आपको, राइट, जो छोटे छोटे रास्पबेरी पाई इस टाइप के कुछ छोटे छोटे डिवाइसेस यूज करके डेटा सेंड करते हैं। तो उस टाइप के डिवाइसेस पे जैसे यहाँ पे दिया है देखो, रगड़ डिवाइसेस टू मॉनिटर रिमोट एसेट्स, तो इस तरीके के डिवाइसेस पे ये इंस्टॉल हो सकता है डेटा कलेक्ट करने के लिए।
और Pi adapter is dedicatedly for IoT and cloud kind of things.
हाँ बोल सकते हो आप, क्योंकि ये क्या है मोस्टली उसी के लिए डेवलप किया गया है, वहीं पे यूज होता है। बाकी क्या है, इंटरफेस एंड पाई कनेक्टर आर मोस्ट यूज एंड मोस्ट टेस्टेड। सो जहाँ पे फिजिबिलिटी वहां पे तो ये दो ही यूज करते हैं, लेकिन जहाँ पे रिमोट है, जहाँ पे फिजिबिलिटी नहीं है, ऑपरेटिंग सिस्टम अवेलेबल नहीं है, उस तरीके की जगह पे एडेप्टर्स यूज होते हैं, जो कि मैंने मेरे लाइफ पीरियड में आज तक नहीं किया है कभी यूज 10 साल में।
अच्छा,
ये बहुत बहुत रेयर रहता है ये एडेप्टर्स, तो अभी अभी आया है पिछले कुछ सालों में, लेकिन रेयरली यूज होते हैं ये। तो आई थिंक आज के लिए इतना इंट्रोडक्शन ठीक है। कल हम इंस्टॉलेशन के प्री रिक्विजिट देखेंगे और पाई सर्वर का इंस्टॉलेशन वगैरह देखेंगे। कुछ क्वेश्चन है आज के लिए?
नहीं ठीक है।
नहीं, और आज के लिए क्वेश्चन नहीं है।
चलेगा।
ये आपका जो ये मटेरियल सब है ये सब थोड़ा शेयर कर दीजिएगा।
हाँ ठीक है, ये प्रेजेंटेशन वगैरह तो दे दूंगा मैं, उसका कोई दिक्कत नहीं।
और एक चीज अनिमेश, एक जो इबा सिस्टम में सुना हो, इबा इबा इज ए कॉम्पिटिटर ऑफ पाई और व्हाट, IBA?
होगा। एक्चुअली पाई के कंपटीटर तो बहुत है आजकल मार्केट में, इतने आ गए हैं ना ये IoT वाले। लेकिन एक्चुअली पाई को फर्क नहीं पड़ता है, क्योंकि जितना फंक्शनलिटी पाई देता है ना, नो वन एल्स कैन गिव। क्योंकि पाई जो है ना वो आजकल में नहीं बना, इट हैज इवॉल्व्ड बाय द टाइम, लाइक 40 years, राइट? तो ठीक है, कुछ कुछ फीचर्स आपको लगेंगे कि यार ये तो पाई से अच्छे हैं इधर, दोज आर मॉडर्न फीचर्स। वो पाई क्यों नहीं दे सकता? क्योंकि पाई को बैकवर्ड कंपेटिबिलिटी भी देनी है, राइट? कंपेटिबिलिटी बैकवर्ड होनी ही चाहिए पाई के लिए। तो उसके वजह से है ना, वो कुछ कुछ चीजें इनकॉर्पोरेट नहीं कर पाते आसानी से, नई चीजें जो थोड़ी ज्यादा अट्रैक्टिव है। लेकिन फंक्शनलिटी वाइज जो बेस है उनका, वो इतना प्रूवन है कि मतलब जितनी बड़ी कंपनी आप कोई भी देखो, आप पेपर एंड पल्प में देखो, मेटल एंड माइनिंग में देखो, ऑयल एंड गैस तो पूरा पाई के हाथ में है। मतलब जितने ऑयल एंड गैस के क्लाइंट है सारे पाई ही यूज करते हैं, जो कि सबसे बड़े क्लाइंट है पाई के लिए। पावर इंडस्ट्री हो गया, रिन्यूएबल्स हो गया, हर जगह पे जितने बड़े क्लाइंट देखो सब पाई यूज करते हैं। क्योंकि क्या है कि जो फंक्शनलिटी यूज मतलब है ना पाई में अवेलेबल, सबसे मेन क्या है कि यू कैन पुश एनी डेटा एंड यू कैन पुल डेटा टू एनीवेयर। दैट इज द मेजर पार्ट। क्या आपको एक्सेल में डेटा चाहिए, एक्सेल में लो, डेटाबेस में डेटा चाहिए, SQL में डेटाबेस में लो, विजुअलाइजेशन अच्छा है, आपको SDK अवेलेबल है, APIs अवेलेबल है। बाकी कोई भी जो ये है ना IoT टूल है ना, वो आपको अलाउ ही नहीं करता इतने सारे वे से डेटा पुल करने को। उनका कहना रहता है कि आपको डेटा मिलेगा सिर्फ हमारे पोर्टल पे ही मिलेगा, हमारे फॉर्मेट में ही मिलेगा। तो उसके वजह से है ना वो उसका प्राइस कम रहता है, क्योंकि वो रिजिड है, तो वो उस तरीके से डेवलप नहीं हुआ है, तो उसका प्राइस कम रहता है बहुत पाई से। पाई बहुत ज्यादा एक्सपेंसिव है।
ये पाई एक्चुअली जो रॉकवेल का जो हिस्टोरियन है वो भी इंटरनली वो पाई को ही यूज करता है क्या?
एक्चुअली वही होता था पहले। सारे जो जो OEMs थे ना, जो DCS वगैरह प्रोवाइड करते थे ना, वो बैकएंड में पाई लगा के छोड़ देते थे। जैसे ये AVDB जो मैंने बताया ना अभी, वहां पे एक्चुअली वही वो कि डेल्टा वी इंस्टॉल करके चले गए ये, ओके।
अच्छा।
और इन्होंने क्या किया था डेल्टा वी के साथ, क्योंकि वो डेल्टा वी DCS था, हिस्टोरियन था नहीं, इन्होंने बैकएंड में पाई डाल के चले गए। इन्होंने पाई एक्चुअली कॉन्फ़िगर किया ही नहीं था, सिर्फ डेटा डंप होते जा रहा था पाई में। 2016 में जाके हमने पूरा मिल इंटीग्रेट किया और स्क्रीन्स वगैरह बनाए।
ओके ओके ओके।
तो पहले पाई जस्ट हिस्टोरियन यूज होता था। मैंने शुरुआत ही वैसे की ना, कि पहले पाई जस्ट एज ए हिस्टोरियन यूज होता था। इट हैज एज अ डेटा इंफ्रास्ट्रक्चर।
ओके, आज के लिए
चलो मुझे
कल
भी
फिर 7:30 बजे।
गले
हाँ
थोड़ा सेक देना पड़ेगा, बहुत
हाँ।
भयंकर।
चलो ठीक है, फिर कल मिलते हैं
ओके
7:30 को। ओके ओके, चलो बाय।
ओके।
रिकॉर्डिंग थोड़ा रख लेना, ठीक है?
मैं वही अभी चेक कर रहा हूँ, रिकॉर्डिंग शुरू तो किया था, अभी वो सेव कहाँ होगा मुझे देखना पड़ेगा। ओके
ओके ओके, चलो
बाय
बाय।
बाय।